सही है। हमारा लैपटॉप लगा पे कॉपी कर देते हैं।
A very good morning to all esteemed dignitaries, guests, colleagues, and participants. With the blessing of Honorable Founder President Sir Dr. Ashok K. Chauhan Sir and Honorable Chancellor Sir Dr. Atul Chauhan Sir, our Honorable Vice Chancellor Sir Dr. Ashok K. Srivastava Sir, respected Registrar Sir Dr. Prabhakar Tripathi Sir, respected Dean MEP Sir Dr. Abhishek Tripathi Sir, respected Assistant Director IQAC Nishant Madi Sir, respected HOIs, HODs, we are now about to begin the inaugural ceremony of the 2 days workshop on the vital role of mathematics in computer science and engineering, organized by Department of Mathematics, Amity Institute of Applied Sciences, Amity University, Jharkhand. It gives us immense pleasure to welcome you all to this momentous occasion. The 2 days workshop seeks to bring together faculty members, research scholars, BTech, BCA, MCA, MTech students from across the globe to engage in critical discourse on the evolving of mathematics and statistics and their application in computer science and real life. This workshop aimed to introduce the vital role of mathematics and statistics in computer science and engineering. Mathematics is the foundational language and logic for computer science and engineering, essential for designing algorithms, analyzing data, building efficient systems, and understanding core concepts like data structure, AI, and cryptography. It provides the tool for problem solving, modeling the real world, and proving correctness, enabling everything from simple code to complex simulations and secure encryptions. A special emphasis has been given to removing the fear of mathematics and statistics and increasing interest in these so that CS and CSC students can do better in their field. With a firm belief that workshop will be extremely fruitful to all participants, I now invite Miss Anjali, a student of BTech second year of Computer Science and Engineering, Amity School of Engineering and Technology, to host the next session. Miss Anjali, thank you.
A very good morning to all esteemed dignitaries, guests, colleagues, and participants. I am Anjali from second year BTech Computer Science and Engineering. Feel extremely honored and privileged to host today's session. With the blessings of Honorable Founder President Sir Dr. Ashok Kumar Chauhan Sir and Honorable Chancellor Sir Dr. Atul Chauhan Sir, our Honorable Vice Chancellor Sir Dr. Ashok Kumar Srivastav Sir, respected Registrar Sir, Mr. Prabhakar Tripathi Sir, respected Dean, MAP Sir, Dr. Abhishek Tripathi Sir, respected IQAC Assistant Director Sir, Dr. Nishant Mani Sir, respected Association Dean Student Welfare Sir, Dr. Prabhat Kumar Tripathi Sir, respected HUIs and HODs, program coordinators of various institutes, schools and departments. We are going to start the lecture series in 2 days workshop in hybrid mode in computer science engineering 20th and 21st February 2026, which is organized by the Department of Mathematics, Amity Institute of Applied Science, Amity University, Jharkhand. I now humbly invite first speaker Dr. Rahul Mishra, Assistant Professor in the Department of Electronics and Computer Engineering, National Institute of Advanced Manufacturing Technology, Jharkhand. Dr. Rahul Mishra has been working as Assistant Professor in the Department of Electronics and Computer Engineering, National Institute of Advanced Manufacturing Technology, Jharkhand, India, from February 2024. He completed his PhD in Computer Science and Engineering, thesis titled as Developing Security Paradigms for Efficient Data Storage in Cloud Environment in 2023 from Computer Science and Engineering, Indian Institute of Technology, Government of India, of Dr. Dharavat Ramesh, Master of Technology, Computer Science and Engineering, with specialization in Information Security, Institute of Technology. His research interest is formal verification, network security, and cloud computing. He has published more than 20 papers in reputed international journals and conferences. One edited book. He has qualified UGC NET 2017, GATE 2014, and 2016. Granted student participation grant for IEEE Technical Community on Parallel Processing, working as ad hoc faculty at Department of Computer Science and Engineering. Malya Institute of Technology from July 2016 to May 2017. Assistant Professor, Department of Computer Science and Engineering, National Institute of Technology as an Institute of National Importance, 2017 to May 2018. Assistant Professor, Department of Computer Science and Engineering, Graphic Era, Dean to be University, times higher ranking 60800 and in 5 Dehradun, Uttarakhand, India from March 2023 to January 2024. He is going to deliver an invisible equation how mathematics secures and shapes the digital world. Yes.
Good morning. So, first of all, I thank to this organizing team to organize a very important lecture on the topic which brings together two things, mathematics and computer science. Because in present time, very less people who understand this relationship. Because most of people have a idea about the computer science is a different thing and mathematics is a different thing. But in KIT, mathematics is the heart of computer science. Without equation and mathematics, there is nothing in computer science. So for today's lecture, I will start from one or two simple questions. Like, how many of you use the Google Map? Maximum number of, or how many of you use online like PhonePe today? Maximum. And how many you watched YouTube, Netflix, Prime? So whenever you made any online transactions or you open a Prime or YouTube, you see predictions on the basis of the previous working movie or so what is in that base? How about the movies at your choice, or this or always find the sorted path on a different scenario. Like sometimes depends, sometimes the things are more. So the idea, mathematics, good, but how mathematics? Most of people say there is some good. So it's very good. You have idea about these things. Mathematics is behind. Number of equations which are just the code. This is a simple program, and on the basis of this code, we will get the output either for the any prediction or for the secure transaction. So from first case, Netflix or Prime, on the basis of the previous seen, get some predictions. So this prediction is a combination of matrix and probability. How? In generally two types of matrix. One, your choice. Okay, thank you. So first matrix is your choice. Means you have seen some movies like drama movies, thriller, or every movie has different aspect. Like some part of drama, some part of comedy, thriller. On these different parameter, your movie is characterized. After that, another matrix, user choice. Sorry, movie choice. One is your, second is movie type. So on the basis of these two type of matrix, a different parameter will generate, and each time when you open Netflix, so on the basis of your previous movie, a new prediction will appear. Second, when you open the map, always find the shortest path. So the mathematics we have said the same matrix and another optimization problem. A matrix and the equation to find the shortest path, because we have no option from source to destination, but we always prefer the shortest path. Now the third one is any online transaction, we always want the transaction make secure. Like if we want to be condition for 500, so only 500, not less or than 500. So behind this, a number of equations are working. Last and very important, which is very trending in present time, AI and ML. Without the mathematics, like mathematics, calculus to find the optimization, different statistics, AI and ML is nothing. It's totally the basis of statistics and probability to find the better predictions. Another part, software. In computer science, when there's design some code for some industry, but when you design a code for design software as per the client requirement, the final point how you test the design code or software is valid or not. Generally, when you design a code, you just learn to do three test cases and just assume your code is correct. But on the basis of this 3 5 test cases, is it valid? Your design software is completely valid. No, because just 3 5 test cases is not enough to check the validation of any design software. So there is some mathematics, basically 2 part correctness. We check for all cases. If your input is correct, definitely your output is correct. Like you have designed a code, summation of 2 numbers. Very simple code. You just enter 3 numbers, A, B, and C. C is equal to A plus B. Or when you enter the value of A and B, you will get the output of C. But the condition is that A and B should be real number. If you enter some complex number, you will not get the correct output because the software is designed only for the real number inputs. This is the correctness. If you enter the correct only number, output will be correct. If you get the wrong number, output should be always incorrect. If the input is incorrect, output should be incorrect. If the case is that input is incorrect, output is correct, totally wrong. So two things which is used to check the software instead of test basis correctness and software. And behind this, again, some mathematics. Mathematics, a model is designed for this correctness and soundness verifications. So from this number of examples, you have the idea what is mathematics. Because without the mathematics, cybersecurity or the option to design a reliable software. Because if you design a software without proper verification, your software will only work for some cases, not for the all cases. So I will start my session to cover only one topic, which is cybersecurity, and discuss how the mathematics will work as a heart of the cyber security. Means without the mathematics, there is no scope a secure transaction in daily life. So first question, what is secured cryptography? Simple. Send a message to your friend. There is only one aim. Only your friend will be able to see the message. Yes, no? In WhatsApp ad, there is an encryption. And when you see the ad of WhatsApp, there is a term end-to-end encryption. Means only you, means the sender and the receiver will able to see the message. No one else needs to party have option to see the message during the transmission. Either the distance between the source and destination is very, very large. If you are in India and your friend in some other part of the world. So in this case, distance is very large, but there is no option from either the user, means the sender, or the receiver, no one else send your message. Okay? So all this can become on the mathematics. Basically, the prime numbers is a very familiar term for prime number. Very simple term. Everyone knows the number divided by itself as the prime number. It's the heart of cryptography. If we have no prime number, so it will become very difficult to design a very secure communication between the sender and receiver. So the basics of cryptography. This is very fundamental for every student. First is the confidentiality, integrity, and availability. Short term is CAI. Whenever you open any book or any slide for the cryptography, these three terms are always appear. CAI. So the basic or very brief about these three terms is the confidentiality means whenever you send a message on the receiver have option to open the message means end to end only you and receiver. No one, other than these two have option to see your message. This is the confidentiality between the sender and receiver. Second one is the integrity. Whenever you share a file. Okay, so when the receiver receives the file should be in the accurate form. Like you have sent a PDF to your friend, so the PDF should receive in the accurate form without any modification. This is the integrity. And the last one is the availability. Whenever you want service should be available. Like you want to send a mail to your friend, so mail server is be active. Take it. There will friend and the mail service is down. So this will violate the condition activity. A very simple case. Many iPhones and there is an option iCloud to save your data. Let's assume after some days the service of iCloud is down. So in this case, you have the option to see the photos or download the data. So this is a totally the violation of availability because they should always be preserved. So after that, two very basic terms. Whenever we discuss about the cyber security or for secure communication or secure storage of data, and it's very important or very confusing. First one is the policy and second one is the mechanism. Let's assume you want to design a software like PhonePe. So you transaction should be secure. There will be no option to happen transaction before the completion of the transaction. ऐसा ना हो कि you issue the transaction and some 5,000. So your policy is always secure transaction. And second option mechanism, how to achieve these things. Design. You want always a secure connection, but the main question how you will achieve these things. So this is part of the mechanism. It's a designing in order to achieve or objective is refer as the mechanism. So after the completion of your BTech means when you join your company or design some software, the first thing you will design the policies. Means first fix the policy. After that, on the basis of this you design some application, some method to achieve the defined objectives. Means first policy, the mechanism. So these two terms are very important. So if some of you basis about the end application like PhonePe or so there is a defined security model. First, there will be external attackers. First thing. Second, no internal. If we discuss very simple example, many of you have heard about the cloud storage, iCloud. Those who have iPhones know about the application iCloud. After storage of data on the iCloud, there will appear in the real world. Maybe after some time, the iCloud or the cloud service provider will become the malicious. There may be a case, maybe not chances, but there may be a case your cloud service provider like Apple iCloud will become the malicious. But such type of case have already happened in the past. They get data from the cloud, even from the Apple iCloud. So if your cloud service provider will become the malicious, it will become very malicious. Your data will leak. Second case, your cloud service is honest as per the policy, but maybe a chance of external attack. Some hacker will hack the system. So there are number of scenario of attack but whenever we design any security either for the cloud storage or WhatsApp or some other platforms, first design the security policies model. On the basis of this security model, we design the model. Another part is the golden 3A of the cryptography. It's a very basic things. I hope most of you have heard about these things. First one is the authentication, second one is the authorization, and third one is the auditing. So authentication and the authorization, very common but very authentication means for example, as a student, when you enter you need to guard your ID card always to authenticate that insert one or not. This is therefore authentication. When you enter the college, so there will be some restrictions, like some is authorized for the faculties, or some part of the building is only for some staff or some staff. That authorization. This part is only authorized for different type of peoples. So first authentication means for authentication is required. After that, the term authorization comes in the picture. Means which part will authorize for you. And final one is the auditing. Means verification in future. Let's assume in iCloud you store the data. But after some time, there may be case like the case is malicious cloud. Service become the malicious, and case iCloud have lost some data, but Apple has a very well-known brand. If this news will something, yeah, it will be a problem for the Apple. So that's why they want to hide this news. Data is lost. So they will create some fake data. Your data, pretend your data is saved in the cloud service. Our cloud service is properly secure. So in this case, the picture is auditing will come. Each and every time the user will check if the data is in the same accurate form or not. Either in behalf of user, some authority is assigned to check this addition stored data is correct form or not. Okay, so this is the golden 3 of the cryptography: authentication, authorization, and the auditing. So don't confuse about the authentication and authorization. So the basics of cryptography, whenever you want to share a message with your friend, just type the message and press the send button, and your friend will receive the message. So your message refer as the plain text, and when you press the send button, some equations comes in the picture, and the message will appear in the format respond the ciphertext. Like your message is high, so your message send that form of high. Yeah, on the channel means on the internet, your message will appear in some different form, because this is the combination of your message and some mathematical equations. These equations generally refer as keys. I hope machine learners will know about the things keys. Private key and public key. encryption basically. So some will apply this with your message and find the message compared in the wrapped form, and the wrapped form is referred as a ciphertext. And when your friend receives the ciphertext, the reverse process applies at the receiver end. And finally, your friend will be able to see the exit message. So there are numerous cryptography on the basis of these equations or key. Same type of equation or key used at the sender end and the receiver end. This is the symmetric. And another type of keys is used at the sender receiver. So this is asymmetric key cryptography. This is the public key because in the world, the case is Jharkhand, but your friend is some other part of India. Distance is very large. Or some type you want to send a message to unknown people. So in this case, sharing the same key is a difficult task. So instead of the symmetric key, we have some other type of public key. Means you have secret key, but the receiver will use public key. Very common example, when you download the website. So before the password. Okay. So this password is some type of key. I will discuss later of how this will happen. So whenever we want to share some secret media or secret file, all those secret or media file, so that the lead user or the third user will only will access the file. So in case of public key, your message M, then apply some equation like C, and your friend receive the message, and that key is the information, public and private. Private means your secret key, it is public open for all other people. Means it's totally the internet. Anyone can use your public key. This is your internet domain. So this is the method. First, some public and private, and in the combination of this, the wrapped message will create. Like your wrapped message is the positive formation of key is the private key of user. This is applied, and wrapped formation of message with the ciphertext will created. And when the receiver will receive the reverse key, came and finally the friend will able to get the exact message. And otherwise, when the exact ends will transmit over the internet, and the value is channel. And if the thing is shared, so there is a chance of time. So in cryptography, when we discuss about the security, there is a fundamental rule until or unless we are alone. Means we are the alpha say. When we connect with outer always a chance of time. So always take the assumption about the security. So next part is the integrity, the same thing. When you send a message to your friend, so message should receive in the accurate form without any modification. This is referred as the integrity. So the question, the policy is your message received without any modification. I will remember the term policy and mechanism. Policy without modification messages received by the receiver. But the next part is the mechanism. So for the mechanism, let's assume a case. When you log over any website, first option, first thing, enter like your user ID and password. If your password is correct, this one. So successfully log in. If your password is not correct, mismatch. So how these things will happen over the internet with some invisible equation? Sorry, and this equation is heavy. It's a very different type of function, but class functions. Similar functional effects is equal to x square plus multiple. Just like a different type of function is created, and this is the hash message. Sorry, hash function. And the main characteristic or main feature of this hash function is that but it will generate the same size of output. Like you have fixed output size is only 10 bits. Okay, so this output size is fixed. There is no restriction on that input value. If you are on a bit, it will convert to 1 bit. If your input is 100 bit, other will be 10 bit. So with the help of this has, because for example, when you sign up in our website, so you have password first time. So so the same hash will apply and it has for the password and it will say the server. In the next time when you sign in, and if you enter the correct password, so the correct hash will generate and the hash will match. Like in this way. If you enter the wrong password in the sign-in procedure, the hash value will mismatch. This is a very simple example of the integrity of the hash function. Password thing. So after that, next for the reviewer band is that when I want to share some secret documents, so as I always talk with this document side, so they just know it. When you see the massive competitions, they will sign on the last part of the massive. Other registration authorized authority. So after simply sign, everyone can the valid mark sheet. So the basics also means the main part of this verification is the signature. So the hand written sign is possible, but information there is also digital signature. At a signature is used of the document. The method is different. Policy is same. We have to check that document is correct or not. But the mechanism will be different. In the just take a pen and sign over it. But the online means digital signature. And same things in the picture. Some set of key will generate it. And on the basis of this key, and the combination of hash value, that is the sign will be created. Like so. We have a large message, your document, apply hash value. This is designed by you at the initial point. Like you have designed the output will have designed input. So your document will convert into 10 bit. After that, a key will applied. First hash, then key will apply that key. Then finally, it will transmit over the receiver point. Or when the receiver receive this file, so two things will share over the channel, means the internet, the actual file and the hash value. So when the message is received by the receiver apply the same procedure because the hash function is a public function. The same hash will apply over the message, this one, and a reverse key will receive the message of the message, and if these two things are matched, then the document is valid. Policy is same. The signer out of the sign, anyone can valid the anyone can just include the document is correct or not. But the mechanism is different with the help of some equation like function of hash and some pair of keys. We have achieved the policies of the verification of any document. So there is a example. When you received a from your friend, so your friend have applied the digital signature over the document, and you have the part of the level. So you have the public key. Because this is a simple public. So just applying this public key and your the document is assigned is valid. Sometimes you have received the friend and they will the sign the document is a digital sign. So there is no verification. Generally, download from the internet, like university site or site. So on the last part of the there's a PDF will do sign sometimes the verification because you are the student of this university or the so you are the member of this company, so you have definitely the public key. If anyone else who's not the part of this university or the validation, so in this case, if the person receiving the document will not be verified because the person has no public key option. So, a real example of the digital signature. The next point of the next concern which arises from this scenario is that the receiving the public key is it correct or not? Because you are internet, you are connected to the outer world, or when you connect with the outer world, in the always rest of time. So it's a very risky to always the receiving key are the correct one. Keys are very important for the application and other things, but the main part, the received key is correct or not. First, check the key. Sometimes maybe the key is not correct. Let's take an example. In recent time, the several times. Sometimes you have received a wedding invitation card, and when you open the card, a will install in software in your phone. That's right, prototype. Because you have received the credit card and this card will open because you have received this message from your and you are WhatsApp network. So there is no need of public key, just open and click. In this case, the received applications are not valid one because they have some malicious bugs. So always aware you are the received public key is correct or not. So the method is that public key certification. First, certify the key is valid or not. After that, initiate the process. So it will happen with some centralized authority. So the generation of this key will initiate from the end of this some third party, and this third party has some identity which will help to prove that is public key will always correct one. First one, the first step, always the users of the register with decentralized authority by saying your ID card or some other type of identification. On the basis of this identification, the key will be generated. Initially, the key is random information. There is other terms will include in the key, but now the key will generate with the combination of all users ID. User ID with some equation, and final key will generated. But initial only some random keys. There is no user identification, so that we have no option to check the received key is correct or not. So with the help of this certification authority generally prefer as a CA, we can easily check to the received public key is correct or not. If it is valid, then we can apply the key and open the video. Very simple example in the real world. Sometime when you open the website, so there will be a certificate of the site is not valid and site will not open. Sometime. So this certificate actually when all the sites when it should website to first register with the centralized authority. Then the centralized authority generate the respective keys for all the reflector. So when you open the site, the public key will automatically download that this is the value because this key will generate from the certification authority end. So if the certificate is valid, then site will open. Or very simple, if you observe somehow on the website, type of color, observe. If you initiate any online connection or enter your but if the color is red, left portion आप आएंगे so there is a correct portion red or green or if you observe very subtly then there is a term HTTP hypertext transfer protocol. There are two different versions ACK or sometimes HTTPS extra X. If this extra X is present, the color is blue. If this extra X is not present, the color is red. Means you are at on your risk. If you enter credential, means you are on risk. If anything will happen, you are responsible. If initial any condition, you are at risk. Purchase anything over the any website like Amazon or Flipkart. So you when you initiate the transaction on the transaction page in the footer there is a one dot. You are 128 bit signal secure channel. If you observe, और होता है जब आप observe visible on the side, so it's indicate you are on the correct channel. Let's assume that someone has created our website. Flipkart website is secure. Say, some attacker changed the payment link. On payment link, a different link will appear, and in this link, you will with one URL. This type of thing. Like sometimes you have received a message and when people are present, a fake site will open. Very common attack. So if anyone any attacker successfully performs such type of attack like change the payment link or this platform Amazon or then it will appear. So your website will always secure with the help of certification. Always see the type of certificate. When you enter the settings, when let's assume you have a website, so out of this one certificate, when option, this type of pop-up will appear, and from this you can easily find out who is the owner of this website, or this website is properly certified from the correct certification authority. There are different terms, and one option is the certificate or digital sign by the issuer. Means like when you open or click the three dots of Flipkart. So this certificate will appear, and in the option of digital signature button of Flipkart. So it's indicate the site is fully secure. There will be no risk. If this option is different, like digital signed by some other one, so there is a risk. So this is a real world scenario. First, where when you visit an website, browser, like your browser is Chrome, then it's a responsibility to the certificate of this website is valid or not by seeing the digital signature in the last slide or the owner name or some other parameters. And all these parameters will again generate from the set of equations, mathematics. And finally, the certificate moves to the issuing certification authority. If the certification authority assures the certificate issued by me, so everything is open, the side will open. Then the third stage is the certificate authority confirm this certificate of the site is safe, not issued by me. Then the certificate of the site is not correct. So if you by other option, so you are at your own risk. Generally, when you have a antivirus system, when some suspicious site, the alert will appear, and the antivirus always stop. You will not able to decide. You have one option first, disable the antivirus, then site will open because the antivirus will check the certificate will not correct. And the next point is again authentication. When you enter your college, the guard will check your ID card. You are the real one or not. So the same thing. Until we have checked in the terms of first part of CA, check the validation of sender. Sorry, receiver. And the CA and the see receiver who will receive means my flag. Yes. The authenticity of receiver. But to go to the just sender. The sender is malicious. Sometimes this is some message fake card which has some malicious bug, suspicious sender. So in this case, you are the correct one. You are the correct one. The receiver authenticate, sender is not. So if the receiver check the sender's authentication. So another part of authentication where we check the sender is correct or not. Like the person, this one send a message to his friend. So the receiver one first check the sender is correct or not. This is referred as the authentication. When you initiate any online transaction, the bank has checked you correct one or not. Means the account you want to access is not. This is authentication. The second you can then apply in the online version. The same thing. When you enter the credentials, the health will check and the signature will check, and this is the formation of such type of equations. Fx is equal to x square plus 6 plus 5. This is the initial. When you sign up, the hash of your password of your and user ID is x square plus 6x plus 5. This will say over the server. In the next line, when you sign in, and if you enter the correct credential, so the same hash in this the x square plus xcx 6x plus 5 will generate. If you enter any one of it is incorrect, like your password is ABC123, first 5 are same ABC12, but instead of 3, you enter 4. So just change your generating the equation will definitely change, and the matching will fail. So it will indicate you are not authenticate one, because if you are the correct one, you have definitely the correct credentials. So the method is very good to check the validation of the sender. Initially, we had option to check the receiver, but now we have the sender also. But in this case, there is a very common attack. During the sharing of key, your secret, if some attacker checks the secrets, there is a caution, because with the internet, how to work, it is totally public free. Apart from you and your friend, use the same internet at the same time. So if anyone checks your credentials, the number of keys, the all things will be vanished. You will not receive the proper key in the next time. So the number of attacks which are always available over the internet. So we always try to design very secure channel. Last, very important topic and very trending topic, which is the blockchain. I hope most of you have heard about this topic. So in blockchain, if we discuss in digital world or current time, when you initiate on transaction, like you to send 100 rupees to your friend, you have initiated the transaction. This transaction is valued on RBI. There is another centralized authority who have the transaction done or not. Try to check the transaction done or not. So let's assume the centralized authority, like your bank or RBI in future. Then all the will over. So instead of this, if you interact question or to check the action, it would be better one. Instead of the to check the action. In blockchain, instead of a centralized mind, number of people will involve to check all the transactions. So it will provide more security than the current transaction is less secure if we avoid this type of scenario. So blockchain comes in the future when we require more security. So instead of a single one, number of people, these three will involve to check the transaction is right. And this verification is referred as the consensus. How many of you know the term consensus? If you idea about the blockchain, no one. Consensus is just a your will agree. May on this will agree. Like you have initial transaction of 500. So when this transaction is initiated, so number start validated, but on the basis of consensus. The consensus is that the transaction 5 consecutive 0 in the last. Maybe. So all of start finding the value where the hash value of the transaction maintain 5 probability in the Z. Out of these 3, anyone can find, and those who will find the first, this condition will get the reward. And this set of people will prefer as a minus. Finally, the value which has last 5 go to 0 will add in the blockchain. Is a new block. And this will become fully immutable. There will be no option to change the data over the blockchain. So very simple example, marksheet verification. About the case of marksheet. Everyone can generate the paid market by some thousand rupees or some like rupees. So if we implement the blockchain, so maybe a secure environment will create for the market storage in the generation of the. Let us make case. The instructor will enter the ERP case, online portal. Instructor enter marks. When the instructor enter the marks, a particular marks will be generated. Then the authorized people like associate deans will generate the transaction. And this transaction will share all the people of examination cell. Means the minor of the examination cell. Basically the deans. Then deans will check the mark sheet is correct or not by using the hash. And finally it will add to the function. And the your mark sheet is generated, it will generate on the behalf of mark sheet, and the block ID is ABC123. This block ID will share to the student instead of the mark sheet. Along with the hardware shared, but along with this block ID is also shared. So in future, when your company and then check the your money is correct or not. So instead of saying so should have this, they just say ABC123 and share this block ID to the institution. And the institution just enter this block ID ABC123. If this is a correct, means your mark sheet is generated in the past and in the proper way saved in the block, because this block is fully immutable. First, store mark sheet in a secure way, and finally the verification is very limited, because sometimes the verification task is very tedious. The company or the organization send the mark sheet to you. Then examination cell will check the mark. This is very time-taking procedure. So instead of this, a block ID will share, and the examination cell just enter the block ID. If the block ID is present in their own blockchain network, means everything is correct. Means this will be the directly generated in the past, and the data is correct. Okay. Apart from this, blockchain is also in application like healthcare, healthcare data is very sensitive. So in real life, we can use blockchain from the market or healthcare like agriculture or even the government of India, some state government, the blockchain for the land record management. Government of Telangana. So with that, they have implement the blockchain for land record management. So no one has option to change the data. So finally, thank you. But before the last slide, I want to add on things. When you open our table, if you say that there is no option to change. But let us make it in the healthcare. A doctor has you and your prescription saved in the blockchain. But after some time, the medical team has observed some not correct, some mistake by the doctor. The prescription was saved in the blockchain. There is no option to change. So that description of services, then there should be the option to change. So a new type blockchain has also the option to change the blocks. Change, but there's some restriction and different is designed for that. Some such type of architecture, and one of this Australia, they have such type of facility. They blockchain in their healthcare. Blockchain. They have option to change in the future, but with some conditions. Okay. Thank you. And I hope in last you have an idea why the mathematics is referred as the heart of computer science, because without the equations or numbers or mathematics, functions, relation, there is no scope in the computer science. Database is linked with the relation. Without the concept of relation, there is an option to create the database. And I hope all of you have idea about the relations and functions. And without the function, there is no option to achieve the secure online transactions. Thank you. If you have any questions, then
Now the question session, इसको जो पूछना है सबसे, ठीक है, एक क्वेश्चन फॉर वन स्टूडेंट, क्लियर? बेटे, माइक सर, माइक. हाँ सर. हेलो.
So whenever we open a website, so there's an option when we log in it, login and password. So there's an option that we can save the login and password. So that next time we visit that website, so we do not need to enter the login and password. So sir, is it safe? Sir, another one can open the website and directly can log into it without entering the password.
definitely, actually, the case is that I will have some small amount of memory. There can say it's a options. If you want to save credential on the cache of the browser, means you have on the secure system of the browser, then it's okay. But if the security system of the browser compromised in future, then things will totally change. So, option if you want to save, then say, but it's on this. So always try to avoid the same data. So save your password on any browser. Always deny it. So option is clicking next time when it's next time because when password say site will open. You get your time for it first. But is a problem. And problem if the system is compromised, the password will lost. Many incidents have already happened in the past where some attacker or group of attacker launched some attack or some sort and the password. This is dark web. I hope you have heard of the dark web. You enter in the dark web, your password is visible. Anyone can purchase the password. So, always save your password out of the browser. Any other point?
Yes, sir. Thank you.
So, as you said that the Telangana government implemented blockchain technology in land records. So when we apply the blockchain technology in sector, the problem is change and change the records of the particular nation. But when we implement the blockchain technology in land records, when we sell our properties to anyone else, then we should have to transfer our land records to anyone else. Then we have to change that particular thing. Then how can it be sustainable in one time when we have to change blockchain technology in particular person like very correct. So, first, we are present implement in land record. For example, some cell on X. So the data itself, a new block will be created, and we have entered a hash table in behalf of our end. This hash table includes the mapping of all the blocks for a land, like land A and land is at times. So we case, if we make a type of hash table, and in future the size of hash table will become very large. So the another problem, the management of this hash table. So instead of using the traditional blockchain, I have already mentioned some countries have some different type of means advanced blockchain where we have option to change the previously generated block. Like there is a block in behalf of land A, and if land A will sell in future, the same block will modify with some defined condition. They will create a new block on behalf of this same land. So the task of managing hash table in and which will require extra storage will add. So till now we have option to apply this advanced form of blockchain. So we have only option to manage a hash table. But if in future, if we have option to implement this type of blockchain where we have option, so this task will become very easy.
Means that we are not going to change any records on current chain, but if we develop the advanced blockchain, then we can modify the hash tables of the particular section.
In case of advanced blockchain, like there is a land A, a block will generated in the behalf of this land. So in future, when this land will sell, instead of generation of new block, the same block will modify with the name of new seller or some new entries. In case of advanced blockchain. Okay, but in the current form, we will generate a next block and a hash table will manage, and this hash table has entry land A has now two block, previous block and a new block, and these two blocks have some different entry. In previous block, the previous seller name, and in the buyer name, and in the present block, a new buyer will added. Okay.
Getting the point. Thank you so much, sir.
The other point.
I have one fusion. What is the mathematics behind blockchain? Because I didn't get that fully. What is the mathematics behind blockchain?
Basically, the mathematics is the functions and the special part of the function. If the function is a function, it's a function, and the function is the hash function. Okay, and this hash function has some special type of characteristics. They have generated type of argument. So in so it is fully invertible. And second property is that M, and you have the hash of this M, and if you have some different message and hash of different element change. So like your password, if you change a single password, your final output means the final different. So the hash and the sign will fail. Okay. Thank you. Sir.
Hello, sir. I'm Krish. So my question was, what technical foundation skills separate a researcher in your field? Because looking at your profile, you are in cloud security, blockchain, and privacy-based messaging apps. So, what are the skills of a researcher in your field, and what separate them from a software developer? Because when you say that software developers also test their apps for those privacy concerns, and also after the advent of AI and recently the founder of Anthropic, he quoted in World Economic Forum that most of the works of software developers is going to get replaced in a few years. Will AI automating the code in cybersecurity, will the role increase or decrease?
Uh, the first answer is the end totally wrong, because when let's assume the AI the code or design the software, and who will check? Who will design the model to check the correctness of your software? Because the designing of model is the two part, policy and mechanism. So when you design the policy, means the model, and the model totally follows some mathematics. So to check the correctness of your software, we always require some human beings who will design this correctness model. So the term the coder very different. Some will betray, but not all. Okay, and the first question about my research point, what are the technical foundation to research in the cryptography? The first part, mathematics should be strong, because the security is totally achieved from the set of prime numbers of some equations, function, and relation. If you are very strong in the mathematics, definitely you will become a successful cryptographer or security designer in future. So first, clear your fundamentals, mathematics, basically functions, prime number. Then you will definitely understand these things like signature, authentication, encryption.
And
Thank you.
Thank you.
Thank you, sir, for that highly insightful and enriching session on behalf of the participating gratitude. We request Dr. Chandra Chattopadhyay,
अभी ऑनलाइन आपको स्कूल पे जुड़ जाइए और लंच करने चली जाइए, ठीक है? यू विल अगेन हियर एट 12:55 बात क्लियर? तो आप लोग लंच करिए, लेकिन जून पे करिए, क्योंकि ऑनलाइन सेशन स्टार्ट होने वाला, ठीक है? अंजलि,
A very good afternoon, esteemed visitors, guests, colleagues, and participants. I am Lakshmi Pandey, a second year BA student from the Department of Computer Science and Engineering. Fields session. I now humbly invite distinguished speaker, Professor of Physics, Mathematics, Computer Science and Engineering, School of Western Australia. Professor Dr. Amitava Datta. Professor Dr. Amitava Datta, as a professor.
और ऑनलाइन ज्वाइन कर लीजिए, हाँ ऑनलाइन स्टॉप करिए, हाँ हाँ फुल लिंक भेजे हैं ना, तो ज्वाइन करके 12:55 स्टाफ यहाँ आ जाइए। तो हम लोग मैथ कौन क्या होता है हमारे IIT भी है ना आईटी मद्रास से सब हाँ तो जब मैं हमारे बढ़िया पेड़ से वहां से तो सामने काम नहीं ज्वाइन नहीं काम को गए तो खेलने वालों के लिए पड़ेगी आने वाले 10 मिनट तो वो फ्री में सिखा सकते हैं
Hello, can you hear me? Can you hear me?
Yes, sir.
Yes. Yes, sir.
Hello.
Yes, sir. You are
Hello.
audible.
You are audible, sir.
Hello.
Hello, sir. You are audible.
Hello. I cannot hear you though.
I Professor Physics, Mathematics and Computer Science and Software Engineering of Western Australia. Professor Dr. Anil Datta. Professor Dr. Professor in School of Physics, Mathematics and Computer Science and Software Engineering, University of Western Australia. He had completed from Madras and IIT. He is biofunctions, computer graphics, bioinformatics, optical computer, virtual reality, and immersive environment. He has published more than articles, 70 conference papers, 2 chapters, 4 review articles, 6 more than 50 research articles with 2,148 citations and 27 H index and has 4 books, Cancer Genetics and Therapeutics and Genetics and Epigenetics of Breast Cancer. It's by Springer. He is currently writing a book as Essential Quantum Algorithm published by Springer. He finished 7 funded projects from various world-reputed funding agencies. He got Best Editor Award in the National Conference from 2017. He is also the chief editor and reviewer of international journals. Successfully editor of quantum mechanics. So, so So now we can start.
पहले आप start कर दीजिए, आप stop कर दो। Wait करो।
So am I audible? Hello.
Yes.
We can start. Hello. So
Yes, I can. I guess you can hear me, but I cannot hear what you are saying.
तो तो ये अनम्यूट नहीं था इसलिए सर लैपटॉप अनम्यूट नहीं था.
Okay. Good afternoon, everyone, and thank you very much for inviting me to give this talk. I understand that it is a talk on mathematics in computer science. However, I'll not use much of mathematics. I'll try to introduce you to an area of computer science that you may not be familiar with, and that is quantum computing. Actually, quantum computing is one of the most interesting and important technologies in the modern world. Both quantum computing and communication, and government of India and many research institutes in India are investing a lot of effort and money to develop this area. In particular, Government of India has the National Quantum Mission, which the aim is to build quantum computers and also to train young people in quantum computing. So I will give you a brief overview of one particular aspect of quantum computing. It is called quantum non-locality. And to start with, quantum computing is an area which is on the interface of computer science, physics, and mathematics. So if you are not familiar with quantum mechanics, this is a brief note on quantum mechanics. It is by no means a lecture on quantum mechanics, but you may or may not know that quantum mechanics is behind almost all the progresses we have made in the last 100 years. Almost all the comforts of life that you are familiar with, your phone, your TV, your Zoom that you are watching now, everything is due to quantum computing. We colloquially say that electronics is behind all these, but we have designed these electronic devices based on semiconductor technology, and that technology we have understood using quantum mechanics. And also we have understood all sorts of physical phenomena over the last 100 years, from how stars work to how inside our body, our cells work, everything, there is a background of quantum mechanics. So I'll still talk a little bit about quantum mechanics. And quantum mechanics was proposed in 1925, exactly 100 years ago. As I said, it has transformed human civilization, but there are many mysteries in this theory that we still don't understand well. And today's talk is about one of those mysteries. It is called quantum non-locality, or more technically, quantum entanglement. So all the technology that we are developing now using quantum mechanics or quantum mechanical principles heavily use this quantum non-locality or quantum entanglement. So there is a mathematics behind it. Since this is the workshop on mathematics in computer science, I have to tell you that the mathematics behind is linear algebra, Hilbert space theory, and related areas, partial differential equations, and so on. But today's talk is not about using those mathematics. I'll just try to intuitively explain quantum non-locality, and hopefully you will be interested in pursuing this or understanding this further. And you can ask me questions if there is time. I'm extremely sorry for the delay because I couldn't join the Zoom session. So I'm really sorry. Okay, so let us start with quantum basics of quantum mechanics, which we'll require for this talk. Now, all of you have seen a coin. This coin you may not have seen, you are too young. Actually, this coin, we used to buy things with this coin. It is called 3 paisa. So, but now it is no longer in circulation. That is why I have used this picture. So if you keep a coin on a table, it will show either like this or or like that. So it is the head or the tail. This is our everyday experience.
Yes.
When we toss a coin, we sometimes get head and sometimes we get tail. We call it random. The coin toss is a random phenomenon. But actually, this randomness is due to our lack of knowledge. If we know the exact force when we are tossing with our finger, how the coin is made, what kind of metal is in the coin, air temperature, humidity, everything that we can know, if we know all of those, then every time we toss a coin, we can predict whether it will fall head or tail. So these are hidden information of coin toss. A coin toss will not look random if we use all this hidden information. Now, there is some notion of randomness, or actually it is not randomness, rather superposition in quantum mechanics. A quantum coin, something, let us assume there is something called a quantum coin, is both head and tail at the same time. It does not have a definite state if we do not look at it. By looking at it, which is a very difficult concept, what it means to look at it, maybe you can think of, we can take a picture of it or something like that. Until we take a picture, the coin is neither head nor tail. Now, this is very difficult to digest if you are hearing this for the first time, because in our experience, if I have a coin like that in the previous picture, it must be either head or tail facing upwards. But a quantum coin doesn't have that property. It is both head and tail at the same time. That is why I have put a blurred image to indicate that it is both head and tail, as if the coin is rotating very fast. But it is not like that. It is in both states at the same time. So you may think that, okay, it looks like, again, we are missing some hidden information. That is why we cannot say whether the coin is head or tail. But it is not so. Actually, this question has been investigated for last 100 years. Believe me, library full books have been written on this point, and still we don't understand very well. Only thing we know is that no hidden information can resolve this problem. So we have to accept the fact that a quantum coin is both head and tail at the same time until we take a picture of this. So this is called quantum superposition. An object stays in two possible states at the same time in quantum mechanics. We write this as H for head and T for tail, H plus T. to indicate that that is the superposition state. So here is the difference between a classical coin and a quantum coin. A classical coin, just like the coin I showed you, we keep it in a box. If you like, you can imagine a 1 rupee coin or something like that. If we keep the coin in a box, we know it is tail. It will remain tail when the box is closed, and we'll find it tail when we open the box. For a quantum coin, if we keep it in the box, we don't know whether it is tail or head. We may find it as tail or head when we open the box, but we can't say beforehand whether it will be a head or tail. So this is what I was explaining, that we have these two boxes, a classical coin, the way you keep it, and it will remain like that. In case of a quantum coin, we cannot say whether the coin will be head or tail until we open it. So it seems like a random chance. This person here in this picture, Albert Einstein, and he was not very happy with it. He once he wrote a letter to a Hungarian mathematician, Cornelius Lanczos, and he wrote that it seems hard to sneak a look at God's cards, but that he plays dice. Einstein called it playing dice, that we cannot say anything about the quantum coin until we take a picture of the coin or observe the coin. So today's talk is his second comment, where he talks about telepathic methods, which is the subject of today's talk, which is quantum non-locality. So to understand quantum non-locality, we have to look at two quantum coins. So if we have two quantum coins, and if we look at both of them, we can get one of these four possibilities. Either both are head, one tail, first one tail, second one head, or both are tail. We do not know what we'll get unless we look at both the coins. So until we are looking at both the coins, we have to assume that they exist in all of these four states. And again, I have to remind you, this sounds very awkward, but that is the best we know, and that is the best we can talk about. So in other words, two quantum coins are in a superposition state of all these four possibilities. Now look at, all of you know basic algebra, and you can, what we call in India, taking something common from two terms. So I can take h common from these two terms, I get h plus t, and t common from these two terms, and I get h plus t. And I can write it as h plus t multiplied by h plus t. Actually, this multiplication has a mathematical meaning in quantum mechanics, but I'll not go into that. So what I want to point out here is that if I look at this one, I can see clearly this quantum coin here and that quantum coin here, the second one here. That means each quantum coin lives in its separate world. If we look, the first coin can be h or t, doesn't matter, but the second coin independently will be h or t. So this is the very simple state of affairs in this case. But there are possibilities where the two quantum coins can be in a superposition state of HH plus TT. Here you can see your normal algebra rules, you cannot take anything common out of it. And believe me, normal algebra rules apply for quantum mechanics because quantum mechanics is a theory or a linear theory. So we can take common as we showed in the previous slide, but here you cannot do that. So in some sense, the two coins live in a common world or joint world. Now, this looks very innocent, but this is extremely deep because we still don't understand very well what this means. Some way, there is a connection between the two coins. It can be HH plus TT or HT plus TH. So the coins live in a common or joint world. This was pointed out first, or this was named first by famous scientist, famous physicist, Erwin Schrödinger, who gave the name entanglement. And there is a very important story behind it, which is called the EPR paradox, or Einstein appears again, Einstein, Podolsky, and Rosen paradox. So they pointed out, you can understand this problem. They pointed out that there are two people, Alice and Bob. They prepared the state HH plus TT. Actually, this kind of state, not for quantum coins, but there are actual physical systems that behave like quantum coins. For example, polarization of photon, a light particle, or spin of an electron, etc., where we can prepare this state. Then Alice keeps the first quantum coin with her. Let us say Alice lives in Ranchi, and Bob takes the other quantum coin to the other end of the universe, as far away as you can think. Now, the funny thing is this. Alice looks at her quantum coin and finds it as H. Now, as soon as Alice looks at her coin and finds it at H, Bob has only possibility to find his coin also as H. So, or otherwise, if Alice finds her coin to be T or tail, Bob also will find his coin to be T or tail. Now, this is very disturbing. What Einstein, Podolsky, and Rosen pointed out that there is something ghostly, or Einstein used the word spooky, is going on. That even though Alice and Bob are at the two ends of the universe, but as soon as Alice does something in her coin, that is reflected in Bob's coin. So this really happens. We have now experimental evidence of this happening. You may say that, okay, how does Bob go to the other end of the universe? Actually, we have systems now where we can simulate that situation, that Bob is going to the other end of the universe. If I have time, because I was late, if I have time, I can explain that experiment to you. Now, there are two things which are philosophical, but we can appreciate the philosophy behind it. There is something called realism in our world, and Einstein was a firm believer in realism. What is realism? Objects have definite properties whether we look at them or not. But we have seen our quantum coin is neither head nor tail until we look at it. But we have now a lot of evidence that realism is dependent on observer. Again, there are experiments either today or if you give me an opportunity again to talk to you, I can explain to you nice experiments. But it seems that unless we observe, really objects don't have properties. Now, lots of people are very unhappy about it. These two gentlemen both are Nobel laureates in physics. Still, they don't believe. For example, Gerard 't Hooft, he is a very famous physicist from the Netherlands. He, in a recent video, he asked the question, is the moon there if we don't look at it? And Roger Penrose is more as we say in English, more forthright. He doesn't believe that quantum mechanics is wrong. Quantum mechanics is correct. He says quantum mechanics is wrong. However, we know quantum mechanics works because everything that we do in today's world based on quantum mechanics. Okay, realism is one thing. Locality is another thing. Locality was a very fundamental property in classical physics, and we can appreciate that in our daily life. If I do something here, something will move. For example, I can push my computer, it will move here. But if I push my computer here, the computer in Ranchi will not move because that is non-local, that is far away. For example, if the sun disappears suddenly, we won't feel it for 9 minutes. The information that the sun has disappeared takes time because that information comes at the speed of light. It takes 9 minutes. On the other hand, recent experiments have shown that when Alice looks at her coin for the HH plus TT superposition, Bob's coin becomes either H or T, depending on whether Alice sees H or T, at least 100,000 times the speed of light. Now, you may say that I'm telling some lie or some story, but it can be shown that this doesn't violate that no information spreads faster than the speed of light. But we will not go into that. So these two are the main bedrock, as we say, of physics: realism and locality. So Einstein thought quantum mechanics was incomplete. There are hidden variables, just like tossing the coin that I told you, that if I know how much force I am giving, how much, what is the coin made of, what is the humidity of the air, etc., we can work out. Einstein also thought there are some hidden information in quantum mechanics that are missing, and we have to supply that, and then we'll know that there is no mystery here. Yeah. So, for example, the idea was that for HH plus TT, this state, the two coins have decided secretly what Alice will see for the first coin and then what Bob's coin will do. That is the hidden information. And that would have solved the spooky action at a distance problem. Einstein worked for a long time on this to build a theory alternative to quantum mechanics. He could not do. And people didn't give much attention. They thought that it's a philosophical problem. It's not important. Now, this gentleman here, his name is John Bell. You perhaps don't know him, but he showed a remarkable thing in 1965. The Alice and Bob HH plus TT problem is actually about correlations. That means if Alice sees H, Bob will also see H. So their observations are correlated. Similarly, if Alice sees T, Bob will also see T, correlated. Now, Bell showed that what he showed is very deep. He showed that we cannot have both realism and locality at the same time. In other words, there is no hidden information that is missed in quantum mechanics. Einstein was wrong, basically. So this is a profound theorem, and basically Bell's theorem you can actually understand. Again, if I get a chance later, I'll explain to you some other day. But today I'll explain to you a very simple version of Bell's theorem, which was experimentally proven by these three gentlemen. Their name is John Clauser, Alan Aspect, and Anton Zwillinger. They received the Nobel Prize for Physics in 2022 for showing, basically proving Bell's theorem that locality and realism cannot be present in the same theory at the same time. Now, today, what I will explain a very simple version of Bell's theorem, which is called the CHSH inequality. It was proposed as a simplification of Bell's theorem by four gentlemen: Clauser, Horn, again this Clauser, Horn, Simony, and Holt. So let us understand. Actually, I will not even explain to you CHSH theorem, but I'll explain to you a game based on that theorem called CHSH game. So in this game, there are two players, Alice and Bob. And there is some other person, just like, you know, the game on TV, Kaun Banega Crorepati, like someone like Amitabh Bachchan asks a question. Similarly, there is somebody, let us call him Charlie. Charlie asks questions to Alice and Bob. So Charlie will ask 4 questions, and Alice and Bob will win if their answers for each question are correct. Now, the rule of the game is this: their answers must match for 3 of those questions. For example, if Alice says yes, Bob must say yes for 3 of those questions. And for 1 question, their answers must be opposite. If Alice says yes, Bob should say no, or vice versa. So this is the rule of the game. 4 questions, and 3 of them Alice and Bob must say the same answer. For 1, Alice and Bob must say the opposite answer. So this is the game which actually we can implement in the laboratory and verify. Okay. So this is the game I explained to you. 3 questions demand give the same answer. 1 question demands give different answers. Now, how can Alice and Bob win? One of the good strategies is always give the same answer. They will always say yes, no matter what is the question. Surely they will win 3 out of 4 times, because 1 question will be incorrect where they are supposed to give opposite answer. So 3 out of 4 is 75% of the time. And they can try to give different answers sometimes. Now they might win the different question when they say opposite things, yes and no, Alice yes and Bob no. Or statistically, but the problem is at least one of the 3 same questions breaks. Occasionally they will win 4 out of 4. But if you run this game again and again and again, on an average, they cannot win more than 3 out of 4. Now, when they decide on the answers that yes, first question, I'll say yes, Alice says to Bob. Alice and Bob are discussing. First question, I'll say yes, you also say yes. So this is realism. Answers of the questions have definite values. So it is also possible to show that randomness doesn't help. If they choose randomly, that sometimes they will choose yes and no, a mix. That also doesn't hold, doesn't give you more than 75% of the success rate. So this is the point, that you cannot win more than 75%. Classical players means when the questions have definite answers, must choose in advance which rule to violate, and that costs them statistically at least 1 out of the 4 questions. This is a strict statistical limit for classical strategy for this game. In quantum version of this game, Alice and Bob do not pre-decide their answers. What they have in the quantum version is they have shared quantum coins, just like 2 quantum coins in the state HH plus TT. Alice takes one, Bob takes the other. They are in two different rooms. They cannot communicate during the game, but they have this shared quantum coin or entangled quantum coin. So these coins are representing the yes and no answer. For example, if Alice has H, Alice finds her coin to be H, she says yes. And Bob finds his coin to be H or T, Bob says yes or no. But we have seen that answers do not have any existing values like yes or no, because quantum coins are both yes and no at the same time. So Alice and Bob share entangled pairs of quantum coins, states like HH plus TT. Before the game starts, no coin has a definite head or tail. Now, when Alice and Bob get their questions from Charlie, just like your game on TV, for each question, Alice and Bob basically look at their coin. So the funny thing about quantum looking at, what I am calling at looking at or observing a quantum property, is that it may not be only yes or no. It may be yes with certain percentage and no with certain percentage. So it is possible to look at a quantum coin with different angles. For example, you can see, all of you are familiar with graphs like this, where the x-axis is H and y-axis is T. And if I consider this as the angle of looking, then if the angle is very close to H, most of the time I'll find H. If the angle is very close to T, most of the time I'll find T. So this policy of Alice and Bob, that they don't have predefined or pre-agreed definite answers to the questions, but when the questions come, they look at their coin, and depending on what they find on their coin, answer the question. So that is the quantum strategy. They look at their coins at different angles depending on the questions, and that is the freedom of quantum logic. In quantum logic, you don't have to prefix your answers at yes or no, 1 or 0. It gives the freedom of extracting an answer with different probabilities if we wish. Now, again, I have simplified this because I didn't want to use the mathematics of quantum mechanics. It's too short a talk for that. But it can be shown, actually, those three gentlemen, they showed that it is possible to achieve a success rate of 85% with the quantum strategy. These three gentlemen I am referring to, Clauser, Aspe, and Zwellinger. And that showed that in quantum mechanics, there is no hidden information. Really, we cannot talk about a definite property of a quantum system like a quantum coin unless we observe it. And that is quantum non-locality for you, because this non-locality is now being used in quantum internet. If you are a fan of science news like me, then you may have heard of something called quantum key distribution, where non-locality is used, quantum computing. If you want, you can use a quantum computer for free. IBM allows you, if you have a free account, IBM allows you to execute your quantum algorithms on their quantum computer. Again, if I get a chance, I can tell more about that. But what I want you to get very surprised, I don't know how surprised you are, but I get surprised every time I look at HH plus TT, the two quantum coins which are at the two ends of the universe somehow know each other's decision. If the first one becomes H when observed, the second one also immediately, instantaneously becomes H. So this non-locality, if hopefully you will learn some quantum computing, and this non-locality is at the heart of quantum computing. I'll not go to the last slide because already I have taken up too much of your time and I was late. That is my fault. Basically, what it says that the two philosophical things I told you earlier, locality and realism, we see those two things every day in our life. But quantum mechanics tells us that local realism, there is no such thing. And there is, for example, we insist, if we think realism should hold, that means every object has a property, whether we look at it or not, then you have to accept spooky action at a distance. Alice and Bob's measurement, Alice measures H, you have to accept that spookily Bob's thing become also H, Bob's quantum coin. And if you don't like that, if you don't like spooky action at a distance, you must accept that objects don't have definite properties, and they are only manifested when an object is observed, like the two quantum coins shared by Alice and Bob. So I'll stop here. I hope I could entertain you. For some reason, I don't think I just checked. I can hear other things on my computer, but I cannot hear anything that you are saying. But if I have time, and if you want to ask some question, you can ask me. Okay, someone asked what we mean by incompleteness of quantum mechanics. Truly, that was Einstein's idea, that something is missing, because Einstein believed in realism, that everything has real properties, even though we may not observe it. So that is what Einstein called as incompleteness of quantum mechanics. Something is missing. But Bell's theorem shows that, I can go into more details of that. Bell's theorem shows that no theory can match the predictions of quantum mechanics if we apply. Basically, no hidden variable theory. This incompleteness Einstein called as hidden variables. So that is the incompleteness. What is the logic quantum mechanics follow? Quantum mechanics follows quantum logic. That is what I tried to tell you. It is a strange kind of logic. It is not our everyday intuitive logic that we are familiar with, but it is completely different. And it has very counterintuitive aspects. For example, the non-locality is one such aspect of this logic. And if you are students of computer science, if you learn quantum computing, hopefully, or I can tell you later also, some other day, then you will see that quantum logic is, quantum computing logic is very different, because we have to utilize these properties of superposition for doing quantum computing. So any other question?
Any other person kindly ask.
Okay. I don't know whether, because I can't hear anyone. So thank you so much for giving me this opportunity. I like to motivate young people in studying quantum computing. Actually, in my university, University of Western Australia, we have quantum computing at undergraduate level. It is part of computer science. There is a specialization called quantum computing, and I teach part of it. And also, I'm writing a book on quantum algorithms, so hopefully it should be ready sometime. And if you have, Joyita, if you have any other opportunity, I would be very happy to talk more on quantum computing. Or I think there are two things in this world which are very, very exciting for young people. I also do research in artificial intelligence. So I can talk on artificial intelligence. I can talk on quantum computing. I can talk a combination of both, because some people are very eager to mix both of these. Hilbert space is a complete normal linear space, and I think quantum mechanics can be explained in Hilbert space. Yes, Hilbert space is the mathematical machinery of quantum mechanics, but I didn't want to bring in any mathematics today. But basically, Hilbert space is the mathematics of linear algebra. So you have to learn. Students who do quantum computing in our university or in my department, they do a course on linear algebra and also a course on quantum mechanics. After that, they do quantum computing. So please let me know on the message box if you have other questions, or if I am eating up your lunchtime. I don't want to do that. You must be all very hungry, but I'll be very happy to answer any question.
The sharing stock कैसे होगी?
Okay, thank you very much for giving this opportunity, and I hope I will present or talk to you some other time again. Thank you. Bye.
A very good afternoon to all esteemed dignitaries, guests, colleagues, and participants. I now humbly invite our distinguished speaker, Dr. Kirti Kumari, Assistant Professor and Head of Department of Computer Science and Engineering, IIT Ranchi, Jharkhand. Dr. Kirti Kumari has been working as Assistant Professor in the Department of Computer Science and Engineering, IIT Ranchi, Jharkhand, India from 2021. Currently, she is Head of Department of Computer Science and Engineering, IIT Ranchi. She completed her PhD in Identification of Online Harassment using Soft Computing Techniques in 2021 from National Institute of Technology, Patna, India. Master of Technology, Computer Science and Engineering from MS Ramaiah Institute of Technology, Bangalore in India in 2014. Her research interest is in healthcare, water quality monitoring, identification of hate speech, cyber aggregation, cyberbullying, quantum natural language processing, machine learning, deep learning, data science, explainable artificial intelligence, evolutionary computing, optimization techniques. She has published more than 25 papers in reputed international journals, book chapters, and in conferences. She has qualified GATE 2012, 2014, 2015, 2016, 2019, 2020 PhD research scholarship funded by Ministry of Electronics and Information Technology, Government of India. From September 2015 to August 2020, She delivered more than 10 lectures as invited speaker, keynote speaker, and resource person in various conferences, workshops, FTP, STTP, STC, refresher courses, etc. She was working as assistant professor, computer science and engineering department, Institute of Technical Education and Research, Shiksha Anusandhan, Improvi University, Bhubaneswar, Odisha, from 2020 to 2021. She is going to deliver on the transformative impact of natural language processing in computer science and engineering. Welcome, ma'am. We discuss about the natural languages. How this natural language useful in our computer science and engineering applications. So actually, these are the outlines of my presentations. So in that, I will discuss what is actually natural languages. Then I will discuss what is the importance of this application. Then also I will discuss about that what are the important real-time applications of NLP. Then I will go through some important terminology in our NLP. Then I will discuss what are the different representations of this type of the NLP data. Then I will little bit go through the how we can actually, as we know that in NLP there will be two components. One will be the text, another will be the words. So basically, I will be focused on text only. So that I will discuss, and then I will discuss about what are the different research orientations that you can search. These are my topic of today's sessions. Okay, so now as we know that actually these are very important. What we can say is whatever we are talking about, I can put it how we are communicating with each other. All the languages are actually natural language. Yes. And this natural language is different from the machine language. Maybe I will be here then. Okay, so actually, this as we know that whatever we have to communicate with the human beings or among the human beings, for those purpose we are using some kind of language, and those language we can informal way we can call as natural language. Yes, as we know, this natural language is having very title diversities. Yes, we know that different countries having different languages. Even in single country, we are having different languages. Even one language are having different variations of the particular language. For example, Hindi, we know that. In Bihar and Jharkhand, there is a different kind of Hindi. In UP or Delhi side, there is a other kind of Hindi. Yes. So like that. In natural language processing, it is a what we can see is called, this is a subfield of like artificial intelligence. There we are focusing on the how our machine can able to understand, interpret or generate like human, how human is producing the output or how human being is understanding things, how human being interpreting the data. In the same way, what are the different techniques we can make so that our machine can also do the same thing? Yes. So that is actually our what we can say those techniques we are discussing in this natural language processing. So actually, in natural language processing, we know that our main motto will be the how we can bridge the gap between the human communications and machine understanding. For example, there are you can see here some examples. Nowadays, everyone are using some kind of this NLP tools. Yes, am I right? For example, maybe you are using ChatGPT, maybe you are using Google. In Google also there is some kind of applications are inbuilt in Google, like how you are your text-based searching, yes, voice-based searching, yes, video-based searching, like that. So those what we can say. So in many of the applications nowadays we are using actually this natural language processing application. For example, we can see like I think you are using Alexa, Siri, yes, many OpenAI, Gemini, yes. So you can feel like one human being is interacting with you. Yes, whatever you will have, it will be respond like a human being. Yes. So how these things happen actually, those things I will discuss here. So here we can see there are many applications, broad applications of this language processing, like sentiment analysis. For example, we can say like in e-commerce website or the human beings, whatever the conversation is going on, we have to understand the actual interpretation of those conversations. So in those things, we are having the what we have to do, we have to analyze the context. Actually, in what context we have actually conversation is going on. Yes. So that will be the sentiment. Another thing is that chatbot. Actually, as we know that there in any any organizations or any companies or any in general, what we are seeing that there will be some automatic customer service. In that way, what will happen actually, wherever we are putting some staff that will be answering the client's questions, that will be not required nowadays. If it is too much repeated kind of queries, then this type of the service can be used. For example, when your parent or you are coming first time for the university for the admission or for any kind of inquiry, then you can, I think this type of service. I don't know you are having or not, but in general, most of the industry in industry or academic institution, they are giving such kind of services. So these two in general, everyone are using. And third type of the application, what we can say, that is machine translation. What I have already discussed with you, like as we know that language is having very large diversity. Yes, various means in anywhere you will go, you will feel like different people are talking in a different language. So how we can communicate with those? If you want, maybe every person is having limitations. No, they may know the 4-5 languages. But it is not necessary that each and every person will know all the languages. It is not necessary. So in those cases, previously, like in traditional way, but here some person was actually translating the one language to another language. But nowadays, we are having some automated tools that will automatically translate one language to another language. That we are calling machine translation. Yes. And third, fourth application, what we can say that is text summarization. Text summarizations are like, as we know that for the representation of the language, in general, we are having two types of the representation. One will be the what we can say vocal components. Yes, another one will be the written communications. So for the written communication, in general, we are using text. Yes. So for example, what we can say, those this most of the web content we are having in the form of text. Yes. So if you want to go through in a quick way, for example, you don't have time to see the entire book. So for that also, I think you are using some kind of applications like sorts and all. Yes. So in that, another what we can say in the medical diagnosis system also, we are having some kind of text summarization. Yes. So these are the very common things, but whatever the applications of NLP, these are very common applications. Everyone can visualize and realize those applications. For actually, it is for in general for human things. Yes. So that is one important application. Another application, what we can say, that is speech recognition, that I have already discussed with you, like in Google search or even in YouTube, we are having the different kinds of functionality of searching. Yes, either you can type and search, or you can the system is recognizing your voice, and then whatever the query you are asking, according to that you will respond. So that will be the speech recognition systems. So here one what we can say that one what we can say important applications that I have shown through this diagram, that is text extraction. Like actually in traditional way, whatever we are representing data, that will be in general in a text format first. And nowadays we are typing and we are doing such kind of type probably. But previously all things are handwritten. Yes. So if we want to interpret those data, then what we have to do? One way is that one human will read that and it will explain. Yes. Or for what purpose it will be mapped with one applications to another applications, like they can do. Another thing, if we want to do such kind of thing in automated way, then what we can do, we can scan those documents that will be in it may be in PDF format or JPG file or whatever it can be. So it will be mostly, those documents will be image form. Yes. Now we have to extract the information what is written in those documents. So for that, we are having one kind of applications, that is optical character recognition system. So through that, we are able to interpret or understand those documents. But for according to whatever you are having the task, for your application, you can do such kind of OCR techniques. Here I have already discussed with you, like you can see, this is the one kind of example of sentiment analysis. In general, you are using e-commerce website for purchasing something, Amazon, Flipkart, and all. So in general, what we are doing before purchasing, we are seeing the reviews. Yes. So these reviews are actually these reviews I have put into the examples that this reviews may be, some reviews are not important. They are actually not telling about the any relevant information to you. Yes. So those are neutral. It may be some comments that will be positive feedback or someone are negative. So in that way, it may be a different classification. Then here I have already discussed with you text summarization. You can see this is one another applications document classification. Nowadays, everyone are using such kinds of applications. For example, like all you all have email ID. Yes. In email, whatever the email are coming, that will be automatically it will be separating the inbox and your spam folder. Yes, how it is actually doing? Actually, AI is behind it. Yes, actually, what we can say in the traditional approach, it was doing this, but actually nowadays, whatever the version of your whatever version you are using, in that AI is into. So that is also one kind of NLP applications. There we are actually what how you are responding, how you are reacting to any event. You according to that, you will observe your reactions. According to that, it will classify into a different folders. Like either it will important. Yes, for your past reactions, it will observe. If it is important, then it will be the inbox. Otherwise, it will be put into the spam folders like that. So again, this I have already told you that how speech recognition system can be useful in different systems. This is again chatbot. So I am seeing such kind of thing. So as I have already discussed with you many applications of NLP. Yes. So actually, how these things happen actually? Yes. How our machine or how our system is understanding the text and language. As we know that machine or computer will only understand the numbers, not the numbers also it will be in binary form. Yes. So actually, but how you are getting the response like human beings? It means that whatever the text you are giving to the system, it is understanding. Whatever the language you are giving, it is understanding. So how this things? So for that, we are now will discuss what are the different steps that we are following for this text understanding or language understanding. Okay. So at first, what we are doing actually, we are doing some kind of text processing techniques. Means in what way you have to give the text to your system. So what will be the preparation of your input? It will not understand how actually how human beings is understanding. Human beings are very intelligent, yes. But machine is not intelligent actually. Yes, we are making intelligent. But actually, by default, machine is not intelligent. Am I right? So for that, actually, in what way we can represent our data? But here, we are having text. So how we can do that? What will be the representation? What are the different cleaning techniques? How we can prepare the data? In what way we should represent the data? Which part we will consider, which part we should not consider. So those things actually in general coming under the text preprocessing part. In general, whatever the real-time application, we are having the noisy kind of data. Yes. So how we can refine those data? Yes. So those things. Then in further steps, we are having the feature extraction and representation. So this is common like how AI, I think you are familiar with little bit AI model. So same thing here also. Now we have represented, we refined the data. So how, and we represented the data. To that, how we can make the important, how we can get the important characteristics of the text data. Those are the things. Yes. And then we can choose the particular models that will be suitable for our use. That will be the NLP, according to your NLP task, or whatever the application you are, or whatever the application you are making, for which which kind of problem or task. For that, what are the different techniques are available? For that, to that, you can select those techniques. Then if it is very simple, then you will get the whatever the results you want. But if it is not, then it may be you want some kind of complex techniques. Yes. So that will be the deep learning and different advanced models. And I will discuss with you like how ML model will be not suitable in many type of tasks. Then how we go further deep learning techniques and different transferable test models. After doing such kind of thing, then maybe we are releasing some kind of what we can say small applications to our target audience, or like how in general we know that in software also we are releasing the beta version. Yes, I don't know you. I think you are first year or second year. So second year. So software engineering is over. So you know a little bit about the software engineering. Yes. So how before releasing the actual version of our software, what we are doing? We have to release the prototype. Yes. And then according to the feedback, we will update our system or software, and then at final steps, it will release the final. So yes, like that we are here in deployment and applications. We are doing such kind of thing. We are doing some validation techniques, then the validation performance, we will update that, then we will completely release the final performance. So that is the actual flow of how natural language processing will be. Yes. Now I will discuss actually in natural language. We know that what are the different forms. Either we can represent through the text or speech. Yes. So if it is text, so what will be the representations? If it is speech, then we have different representations. In speech, how we can do, how our system can recognize in a signal form. Yes. In text, there are different techniques of representation that I will discuss with you. Okay. So those things. Now, actually, in natural language processing steps, whatever the understanding about the natural language is very hard. That again, I will discuss how. Yes. There are two components. One will be the natural language understanding. Another one will be the natural language generation. Yes. Now see, if our system will able to understand, then only it can respond. No. Yes. So understanding is important. Another thing, in what way it will respond. That if you want as a human being, like this, output you want, then it must generate like human beings. Yes. So how natural language generations also can be done. For those entire thing, we are having the different steps in natural language processing. That is, we call lexical analysis, syntactic analysis, semantic analysis. Then if it is like, as we know, this human language part, having not the state part. Maybe previous conversation. After that, there will be what we can say, very subjective images. Yes. And conversation in general is very subjective image. So there will be the importance of context. In what context we are doing. Yes. So there we are doing some kind of discourse analysis that I will discuss with you. So actually this natural language processing are having two different parts. One will be the, I have already discussed with you, like natural language understanding. Another one will be the natural language generation. Yes. So in natural language understanding, what we are doing actually, whatever the natural language we have, how we can, we have to give the input. Yes. So we have, in the same way, our system will not able to understand. So what it will do, we have to make some kind of technique or so that we can represent. So for that, what we are doing in general, we for the text, we are doing the morphological analysis. What we will do, for example, as we know, for the text representation, it will be the set of sentences. Yes. So and sentences of how we are making the sentence with the help of words and rhymes. Yes. So how these words are separated. So what we here in a technical way, what we are calling those words or different symbols, we are calling as a tokens. So how we can separate those tokens? So that related analysis we are doing here, morphological analysis. Then that is not only important. Another thing is that as we have language. For language, we are having some kind of grammar. Yes. Where it will be the subject and object or pronouns or adjective, whatever it is. What will be the rules behind that language? So those grammars we have to understand. Yes. So for that, our system, how we can make our system that can understand those structures. For that, we are having syntactic analysis. Then, as we know, only those two components is not only important, but only understanding the language. We have to understand the meaning. Yes, same sentence may be used for different purpose in different places or for different environment. Yes, so there we are using some kind of semantic analysis. If those conversation is highly contextual, then we have discuss analysis like what is this conversation are going on, like you have in your subject also. Yes, your subject is not randomly assigned. That what are the subjects you are studying in your first semester? Can be this subjects can be the final semester. No, yes, we have to maintain the flow. Yes. What is your background before? From where came out? For what? How? So those we have to maintain. Similarly, here also we have. So those come actually key steps are for natural language processing. Another components that is important in natural language processing, that is natural language generation. In natural language generation, I have already spoken. Like if you want your automated system or models will respond like a human being, that it must generate like a human. Yes. So for that, what are the different techniques that we discuss? In general, we are using deep learning. So this natural language processing is little harder than the natural language generation. Because Can you tell me why? Can you tell me why? So why I can say like natural language understanding is harder than natural language generation? Yes, exactly. Good. Actually, as we know that for the natural language generation, whatever the system is having the data, according to that it will generate. Yes. But for understanding, system is not system don't know about how, in what way the system will get the data. So totally unknown about those things. Yes. So it, many kinds of ambiguity will be there. Yes. So as we know in informal way, how we are talking, we are not totally grammatically correct sentence we are making. We are mixing the language. We are changing the frequent what we do script also. Yes. For example, you can see in social media posts how we are writing. Very informal. Yes, many kind of abbreviations, language differences, hashtags, so like that. But both are harder. Yes. So actually, what we can say, this natural language, what I have already told you, this natural language understanding is harder due to the many kind of ambiguity. Maybe the lexical based ambiguity, or maybe syntactic ambiguity, maybe semantic ambiguity. For example, what I can say, like same words can be used for the different context. Even same sentence can be used for different purposes. Yes. In one case, meaning will be different. In another place, meaning will be different. So, due to those things, this natural language understanding is very hard in. So, actually, what we can say, what are the different challenges of this NLP natural language processing? That one most important, or what we can say, important challenge, that is ambiguity. Yes. Then another one is the language diversity. Yes. It is not like if we have trained for the one model, one language, if they respond for the other language. It will be not like that. Yes. We have to make the another system. Yes. So that our system can able to understand the different language. Yes. Then I have already discussed with you, context is here very important, because whatever the natural language part, here these things are highly subjective. For example, we are also talking in a sarcastic way. Yes. For example, if one student is getting lowest marks in the class and everyone is telling toppers. So if someone are from outside the class, they may feel that they are that particular student is getting the encouragement. What actually is it? It is not like that. Yes. So that's why what you can see, this is also one kind of challenge. Then another kind of challenges in NLP techniques that we can call it data quality. As I have already told you, like whatever the data we have for the natural language processing, those data in general it will be very noisy. For example, here whatever the conversation is going on. Yes. So if we will record, maybe we will get the very different kinds of information. Yes. Outside knowledge, maybe the mixing of voices, something. Yes. Similarly for different applications also. So those overall, I have discussed with you what are the actually technical challenges while doing this natural language processing. Now we will discuss what are the different data in a natural language processing. As we know that these data can be in three different forms. One will be the structured form, It can be an unstructured form, it can be a semi-structured form. Structured form is, structured data means it will be highly formatted. For example, tables, database, those things. And unstructured data means the data does not follow any kind of fixed patterns. Yes, different patterns. For example, text, audio, video, social media posts, multimedia data. So those are very either. Yes. So those we can call as unstructured data. So sometimes some data are not only structured or unstructured. It may be semi-structured. For example, it will follow some kind of structure, but not only fixed structure. For example, HTML file, XML file, JSON file. So why we are these things we are discussing, because we know the data, what kind of different kinds of data in natural language processing. Then only we are able to understand how it can be represented, how it can be processed. Yes, so that's why I am discussing. So again, I am skipping those things I have already discussed with you. So now I will discuss actually how we are representing the text. So one of the oldest or first method of representation of the text, that is bag of words model. So in bag of words model, actually it is very simple model. So as we know, for the text data, we are having the different kinds of the sentences. Yes. So what we will do in this model, what we will do, what are the unique tokens or keywords are having in your corpus, you can make the one tab. You can keep the one tab. Yes. And you can represent each and every document in a sub-vector. I think you are familiar with the vector representations. So for example, you can see here. For the simplicity, I have kept only two documents in our corpus, that I love NLP and NLP. So in that, what are the unique words we are having? I love NLP. Then NLP is repeated. That's why I am skipping this. Only we have to give unique words. Yes. So in bag of words model, our document will be represented with like. Like whatever the words are present, for that we will represent one, in other places we will represent two. So that's why in the first three positions on is not clear. So is it visible to you? Yes. So that's why so NLP what we can say, I is present, love is present, NLP is present. That's why one word. When is not present, red is not present. Yes. So for that we get. So it will be like binary representation. Simply we are taking the either the words is present or not. So in that way we are representing each and every document in a unique way, so that our system will be able to understand the document. Yes. So this is the one kind of simplest model. But we can say method came into the pictures. First model for representation of the text. Another, as we know that previous model, what is the actually drawback of previous model? It will be not checking how much time that particular word present. Simply it is checking that either this word is present or not. Yes. So occurrence is not important for them. Frequency we are simply ignored. Yes. And what kind of words are coming, that is also not considering. For every word we are giving the equal importance. Yes. So sequences, those things we are not giving into our videos. Yes. So for those purposes, another next model is that term frequency, term frequency inverse of frequency. Their abbreviations is also very popular. That TF-IDF factor factorization representation of packets. So what we are doing here, this idea representation will calculate the score of the term frequency as well as inverse document frequency. Term frequency will be the evaluating the number of occurrence of that particular word out of your total words in your document. Yes, so that will in that very simple. That particular word, how many times that appear, that count we have to take, and then total number of words in your document. So that's good. Another thing, so in that way, frequency count here is that particular word, how many times it appear, that will happen. But that is really not important. We have to give the importance to the rare words. Yes, because our motto is we have to differentiate among the different documents. Yes, among documents. Yes. So for that, we have to give the importance to the rare words. Yes, because those rare words are having higher differentiating powers. Am I right? So for that, we are having inverse document. So for inverse document frequency, how we are calculating? We have to have total number of documents we are having in that number of documents containing that particular word. And for that, don't ratio we have to take the log. So again, this idea are having different information. It is one of the variations that I have here, but there are different variations. So here, what actually we are doing? So total number of documents will be fixed for particular columns. Yes, but number of documents containing that word will be, if that word is unique, then those numbers will be lesser. So we are dividing with the lesser value. Yes, so overall we will get the higher value. Am I right? So in that way, we are giving the importance to the rare words. Yes, so we get the idea what we give the importance. It will be like calculated as a term frequency score into inverse document frequencies. Yes, so we are giving the importance to both. Either that particular word is both time occur, its frequency we are considering. Another thing is rarity of the words. Yes, to both we can able to differentiate the document. In that way, we are giving input to our system. I think it is clear. So again, what we can say, whatever this two techniques, we are not considering the where it appears. Only we are considering in previous case only occurrence is important. In other case, term frequency and rarity are. But in what way it appears structurally and not statically. For example, if any document simply mix the words in a jumbled way, you are able to understand that? No, definitely not. Yes, because in language structure is very important. So we are for sequence we are in previous two models we have not given the importance to the sequences. So for that one model came just that is n-gram. In n-gram models we are giving the importance to the sequences. So how it will, in what way it appears before that word, after that word. So in that way we are giving the importance. Yes, so in this model, like we can see, there are different variations of n-gram model, unigram, bigram, trigram, mix of those class models. For example, unigram, if we are saying this unigram model will be like individual words or characters. Okay, so that will be the previous one, unigram. But when we are considering bigram and trigram model or mixed model, then we are giving the importance to the sequences. Yes. For example, you can see like I love NLP techniques. So in that particular sentence, we are having 4 words. Yes. So unigram model will be giving you the individual words we are separating. So those things. But in 2-gram model, we are taking as a key or what key, what we can say, we are taking in one token as a 2 words combinations. Yes. So I love NLP techniques. So here what we are to if it is coming together, then only we are considering. Yes. So in that way, sequences we are taking into the considerations. Similarly, for 3-gram, three words combinations we have to do. I think it is easy. Similarly, for mixed n-gram models, what we have to do, not only we have to take separately these models, we may take 1-2-gram models, 3-4-gram model, 1-2-3-gram models. Means all the combination individual also we are considering, 2 words combinations also we are considering, 3 grams also we are considering. So in that way, our model will understand the sequences or representation of the words. It is not like if it is came, then we see. If means in what order came, it is we are not taking the consideration of their structures or what we can say in what sequence it is. Okay, so that's why this particular model is popular nowadays. So this actually n-gram models are having 2 variations. One will be the word n-gram, another one will be the character n-gram. Yes, some places this character gram is very important. But I can see tell you some examples like as we know, Devanagari script we are using for different languages. Yes, maybe for Bhojpuri, Mathili, we are also using the same. But what will happen sometime? Actually, that particular language is originally it was not for that particular script. Yes, so actually we are representing. We are not able to represent with them. Sometimes we feel that in what actually we are in same way we are not able to represent. So in those type of the contexts, in our applications, your character n-gram will be working very nice. Okay. Again, you will check many type of applications is there. There you may feel like your n-gram model is working very nicely with compared to word n-gram. I think it is clear to you. Concept is simple. So those whatever we have discussed, those 2 models actually those are traditional machine learning system. We are using those things. Nowadays, as we know, we are using the deep learning models. Yes, because complex. In general, we know that machine learning model will be having the disadvantage of handcrafted features. Yes, each and every time we are not very difficult to find out the all those kind of features, and whatever we are taking, maybe it will be not in what way we have to take. Yes, so that will be so most natural what we can say or more automated text feature extraction will be through your deep learning. Yes, so for those type of the representation, text representation, one of the basic text representation techniques, that is word embedding techniques. In word embedding techniques, what we are doing, we are numerically representing words into the continuous vector space. Okay, so it will be like each and every word we are representing through one vector. Yes, and their position will be different. So similar word will be the yes. So if I will get time, then I will tell you that how actually you are checking the similarity that and and similarity matrix for the different kind of sentence and how much relevant for. Yes, so through that we are semantically we are checking that either this particular words or sentences are how much is related. For example, you can see here that through this model we are able to see that this king is a one vector in 5 minutes. Okay, sir. In 5 minutes I will complete and then I will give you the thoda late start one, sir. Okay. So we can see here the example. Then king minus nine plus woman is equal to 3. Yes. I think you are seeing first time this kind of thing. Yes. In word we are doing the mathematics. Yes. Actually, this model will be so the same thing. If you are representing king in a vector space, then this king vector minus this man vector plus woman vector will represent this form. So in that way, this model is representing the words. Yes. So there are different applications we have for those for numeric. Actually, how this model is trained, for that we are using deep neural network architectures. So as we know, in deep neural network architectures, we are having input layer and output layer. In between that, there are many filter layers. Yes, because we have to consider non-linear tools. Yes. In general, whatever the complex task is, it will be not what we can say is direct mapping. In general, we having the composite. Yes, that's why we are using here composite functions. Again, you will get those things in a different sessions. Now we will see like what to have this model are having two variations. One will be the continuous bag of words model, another one will be the skip-gram model. In continuous bag of words model, we are like what we are doing, we are having the many words and we have to predict the another. So many to one. For example, you can see here example like I enjoy NLP techniques. In that, it makes your input will be like I enjoy tests and then which techniques. Like, so 3 words are there. Now you have to predict this particular word. Yes. So in that way, this model is trained. Many to one. So that is the one kind of representations. Another model that is skip-gram model. In skip-gram model, but it will do. We are having one single word and it will map the many. Same example you can see here. We are having the input as an NLP. Now we have that one. In what context this word is that you have. So actually, this both model will be working for any task. But some places that previous continuous bag of words model will work better. Some applications is skip-gram model will work. So again, I have given those details or with examples. You can go through that. So again, I'm skipping those things and. So there are different deep learning model representation of this type of models like globe embedding, fast text embedding. In globe embedding, actually this global vectors of word representations that will be developed by Stanford University. Actually, this particular model is only useful for only English language. Okay, so if you are having only English document or text, then you can use this type of the model. I have kept many things in the slides. If you want to go through that, you can go through that. And if you are having any doubt, you can contact me. Another variations of this word to vec model, that is fast text model. This model is a multilingual model actually. This particular model is developed by the Facebook AI group, research group. And here, what actually, this is little different than globe embedding techniques. Like here, it will also handle the whatever the words actually not given to the training. For those words also it is considering. How it is considering, I don't have time. I will be skipping those things. Again, no issue. If you are interested with me, you can contact me. I will tell you. So this again attention-based model. This attention-based model, what it will do? Actually, it is in general what we are doing actually. You are listening the session. Each and every thing is not equally important. No, something you may feel like it is more important. Maybe you are not. You are keeping into the mind, or you are making the notes for them. Yes. So how human mind is giving the importance or focus to particular things. Same thing we are doing here also in attention model. What we will consider more, what we have to leave, we should not consider. So what way we have to give the attention. So for that also we are having mathematical way of giving the attention to our model, that our model must understand those components. So how it can be that is there. So attention-based model nowadays very popular. There are with many kinds of transformer-based models. Those transformers are different, but we are seeing in our electrical, in computer science or in AI, this transformer is basically different. Yes. So there are many variations of these transformer-based models. One of the popular model, that first model came into the pictures, that is word model. So how this encoder-decoder representation will be like that also you can go through it. There are many variations. Here I have also kept the architectures. Now, little bit I will discuss how actually we are dealing with the code mix data. Code mix data means maybe it will be the mixture of this and Hindi. It may be mixture of your Spanish and English. Like in general, most natural way of representation, in an informal way of representation, in those cases, what we are doing? We are mixing the language, we are mixing the scripting. Yes. So, like here you can see. So, how we can deal for it? So, there we have the different kinds of inconsistent grammars, ambiguity kind of things. Yes. So, how we can deal those type of things I have kept here. So, like as we know that our if you know the language, you are able to predict that this particular word came from which particular language. Yes, for language identification, for you it is very easy. But for the model, we have to train the model in such a way that model will able to identify the language. Yes, so there will be a language identification part. Then, after identification of the language, we have to tokenize those texts. Then we have to normalize the text, because as we know, each and every data or text will be not same pattern. Maybe someone very large sentence, some large sentence, maybe some sentence will be very short sentence. Yes. So how we can normalize such kind of things? So there will be a normalization technique. Then everything is not equally important. So how we can remove some of the words? Those are very frequent images. For example, pronouns. Yes. Adjective, article. Those are not too much important. It is not giving. It is not give you the. It will actually not give you the. It is having less differentiating power. Yes. So those words we have to remove. So those things I have kept into the here. Some with examples. Another one deep learning representation that we are using nowadays also, and that is very simple representation. That is one-hot encoding. It is, you feel like that this representation will be the like bag of words model, but it is little different if you will check. Like here you can see, like here also what we are doing, we are having the set of unique tokens. And then what we will do, for actually, this is for the word representation, not for the, this one hot encoding for the word representation. In previous, we are bag of words model, we are representing the total document. Yes, in that document we are representing. But here what we have to do, we have to represent the words. So position will be the we are keeping the importance to the positions, that if this particular word is present in that place, it will be one, and in other places it will be two. So in that way, vector representation of your words. So those things I have kept. You can see there are different, how we can deal with the code mix data, that we are having different kinds of word variations. There are multilingual transformer based models, character level representations model. Yes. So you can go through it. It is very easy. Now I will discuss little bit like what are the different research direction in this natural language processing. So actually we are having the vast directions or many different what we can say open challenges for addressing this natural language processing task. For example, as we know that those data are multilingual in nature. So maybe the exploration of multilingual data, maybe again it will be the open issue. Yes, it is not addressed. Maybe it is addressed for the one particular language, for the regional language, still it is open. Yes, so how you can handle those things. Then another component is that how you can check for the multimodal data. Maybe your entire data, maybe text and image, maybe video, audio. So it will be mixture of different modalities. So how you can handle with those modalities. So multilinguality you have to handle for your particular applications. Then how you can do, that is one kind of challenge. That is the one kind of direction you can go through for your research. Another thing, how you can mixing of the data, code mix data. Yes, in same document, same sentence you are having different language, mixing of scripting, mixing of many different kinds of abbreviations, different kinds of. So those things. Then exploration of regional language. Then as we know, in general nowadays also whatever the AI models we have, those are like black box images. Yes, it will not giving you you will not able to understand actually how your model understand. What is the logic behind? Yes. So in general, you are not, so only input and output you are able to map. So what you are giving and what output you are getting. Only through the performance matrix only you are able to evaluate that your model is working fine. But how internally how it is understanding, those things are still open. So there we are having some kind of explainable AI techniques that you can explore. Then nowadays, as we know that this AI generations is a generative AI. Yes, we know. So as I have already discussed with you, only natural language understanding is not only important. If our system will able to respond like a human being, then it is necessary to our system to generate like a human beings. Yes. So for those purpose, we are having what kind of AI variations or advanced AI models that we are calling as generative AI. In those also, you have many kinds of applications where you can explore your research. Then different kinds of large language models, small language models are there that I have already discussed that about different variations. Nowadays you are using the Gemini, OpenAI model. Yes. So ChatGPT. Yes. So those are the large language models. So for those models is still having many what we can say limitations. Yes. You just give, you can do the experiment, you will get many things. Yes. So it will not understand the totally context. Sometimes it will be like very good, but But just if you are giving in a reversal, it will, you feel like how this system is not a human beings. Yes, like you will able to differentiate. So how you can make the systems so that it will be responding more natural way. That is one kind of exploration area where you can work. Yes. So now this is my Google Scholar profile. If anyone are interested with that, you can contact me. Definitely, it was having less time, so I have not discussed many things. So, yeah. So thank you, everyone. If you have any questions, you may ask. Only 2 questions. How are ML models differ from DL models in NLP? Can you repeat? And how are ML models differ from DL models in NLP? The data learning models, how are they different from machine learning models in the NLP system? Yes, very nice questions, basic questions. Actually, as I have already discussed with you how we are representing text. Yes, there are different representations. Yes, so actually, in general, in ML model, what we have to do actually, whatever the data we have, to those data, what it will do, we have to give the some important characteristics manually we have to extract, and then we have to give to the system. For example, I can give you, for example, there are different kinds of flower images. Okay, now you want your system will respond in such a way that it will give you the name of the flower. Okay, so what it will give you, like for machine learning model, you may give the what is the color of the that particular flower image. Yes, then what is the shape of the those image, then different such kind of such so yes. So actually, what will happen actually? So those characteristics manually you are observing, and then you are extracting through some techniques, and then giving to the system. Yes, but in deep learning models, more naturally, whatever input you have, same things you can give, and your model will able to learn the patterns. What color it is, maybe that you don't know about that. Either it is taking the color, shape, or any kind of different types of characteristics about the image. But it will take. Yes. So what will happen actually, if you are in general, if you are having large sample of the data, in general, your deep learning models will work very nice. Because as a human being, or whatever the computation power we have, each and every time it is not possible that each and every features we have we are able to extract. Yes, maybe some patterns we are observing as a human being, but how those things we can extract, we don't know. Yes, so we may miss those points. So deep learning model will be like all those type of the patterns, it will automatically extract from the input and will give. So in that way, in general, your deep learning models will work in general better than machine learning models. In general, what we can say, input representations and feature extractions are different than machine learning models. main philosophy will be the same. And as a classification, we are having similar kind of. There is one kind of neural network architectures are there. Maybe in next session you will get those things, those points. I don't have too much time to explain each and every point thing, but in more. So, okay, I think it's clear to you. Any other questions? Yes, please. Thank you, ma'am, for that highly insightful and enriching session on behalf of the organizing team. We would now like to felicitate you as a token of our gratitude. May I request Smita ma'am to kindly present the memento. Let us give a round of applause.
Thank you, ma'am. A very good afternoon to all esteemed dignitaries, guests, colleagues, and participants. I, Yuvraj Kumar Pandey, a second-year BTech student from the Department of Computer Science and Engineering at Amit University, Jharkhand. I now humbly invite our distinguished speaker, Dr. Amit Kumar Singh, Assistant Professor in the Department of Science in Mathematics in IIT Ranchi, Jharkhand. Dr. Amit Kumar Singh has been working as Assistant Professor in the Department of Science in IIT Ranchi, Jharkhand. He completed his PhD in Construction of Broadcast Encryptions and Multi-Signature Scheme in 2023 from Indian Institute of Technology, Kharagpur, under the supervision of Professor Saurabh Mukhopadhyay. Masters of Technology in Computer Science and Data Processing from Indian Institute of Technology, Kharagpur in 2015 to 2017. Thesis titled Design and Implementation of Public Key Cryptography in Smart Card Operating System. MSc in Mathematics from University of Allahabad. His research interest is cryptography, theoretical computer science, and applied mathematics. He has published more than 10 papers in reputed international journals. He has qualified CSIR-NET 2018, GATE 2015, CIET 2014, offered PhD student position at the Cybersecurity and Network Lab in Innopolis University, Respublika Tatarstan, Russia. He delivered more than 10 lectures as invited speakers, keynote speakers, and resource persons in various conferences, workshops, FDP, HTTP, HTC, refresher course, etc. He was working as assistant professor at Brahmanand College, Kanpur from August 2014 to February 2015. Teaching assistant for NPTEL at IIT Kharagpur. Teaching assistant at IIT Kharagpur during MTech and PhD. Assistant professor at SOA University from July 2022 to March 2025. He is going to deliver on mathematics behind cryptography, securing the digital world. Please welcome, sir.
Thanks to all organizers for inviting me for this lecture. Okay, so good afternoon, everyone. Good afternoon. So basically, today I will discuss how mathematics is securing our data silently. Today I will discuss how mathematics is used in encryption and decryption. When we will send any data from one place to another place, then our data is encrypted so that unauthorized user or people cannot access the data. Nowadays, almost every app or every website is claiming that they are encrypting the data from end to end. For example, WhatsApp. WhatsApp is claiming that WhatsApp is encrypting the data on end-to-end device. So basically, this is the plan of my talk. First, I will give introduction related to cryptography. Then I will discuss some encryption technique, and then I will discuss some signature scheme. So basically, cryptography is a subject or a science where we convert a message into another form so that unauthorized user cannot get the data, but authorized user can able to access the data. So for example, suppose there is a sender and suppose there is a receiver. Now suppose sender wants to send some data to receiver, then how cryptography is used to send this message. So basically when sender sends some data to receiver, so that original data is called as plain text in cryptography subject. So with the help of encryption algorithm, what we will do, we will encrypt that plain text into another message that is called as ciphertext. So basically in cryptography, encrypted message is called as a ciphertext. Then this ciphertext is transmitted over unsecure channel. So after getting this ciphertext, a hacker or any unauthorized people cannot get the plain text. But the receiver, with the help of decryption algorithm, can receive the original message or plain text. For example, there are many types of cryptography. First one is symmetric key or secret key encryption. One by one, I will discuss about this. Second one is asymmetric encryption or public key encryption. So basically, is in secret key encryption, we use the same key to send to encrypt and decrypt the data. In secret key encryption, same key is used by encryption and decryption of the data. You can see here the encryption algorithm and decryption algorithm is using the same secret key. For example, suppose if Alice or sender wants to send a message to Bob, suppose he wants to send just a number 10 over an insecure channel, then he will choose a key. For example, suppose I can take 5 for any number, and what we will do, we will add the plain text 10 by 5, then the encrypted message will be equal to 15. So basically this 15 is known as ciphertext. Then this ciphertext will be transmitted over insecure channel, and at the receiver's end, receiver knows the secret key 5. With the help of the decryption algorithm, he can recover the original message state. But there is some problem in secret key information. The problem is how to share the shared secret key. How to share the secret key over insecure channel. Suppose I am sitting in Ranchi, suppose I want to share a key to a people who is settled in Delhi. Then how to share the key? So that I will discuss in later part. So in public key encryption, this is different to secret key encryption. In public encryption, two keys is used. One is public key and second one is secret key. So what we do in public encryption, suppose Alice and Bob wants to communicate with each other. Alice and Bob are very common name in cryptography. Basically, Alice is a sender and Bob is a receiver. Now suppose Alice wants to send a message to Bob. Then what we will do in public key cryptography, first of all, this receiver or Bob will generate two keys, public key and secret key. And secret key will be available only with Bob, but private key will be available to everyone. Everyone can access the public key. then that public key is used by Alice to encrypt the message, and receiver or Bob will use her or his private key to decrypt the message. So, for example, RSA. RSA is a public key encryption technique. There are many public key encryption techniques, but I will explain about RSA encryption. Still nowadays, this RSA was discovered approx 40-50 years ago by using just simple mathematics, and still almost all of the banking system, everyone using this RSA encryption technique. That I will discuss. But before that, I have to explain some basic mathematics technique that I will use while construction of encryption and decryption algorithm. Just basic mathematics will be used that you have already studied during engineering mathematics. So already you know about prime number. So prime number is a positive number with only two divisor, one and itself. For example, 2 is a prime number, 5 is a prime number, 7 is a prime number, 4 is not a prime number. Then I will use the modulus function. I will use the modulus function while designing encryption decryption algorithm. So for modulus function, for an integer a and a positive integer n greater than 0, the value of a mod n will be equal to the remainder when a is divided by n. That's all. The number a can be positive number or negative number, but there is one condition on the n. N must be positive integer. So for example, 26 mod 27 mod 26. So basically this 27 mod 26 will give you 1, because when we will divide 26 by 27 by 26, we will get the remainder 1. Now what about negative numbers? When we will take or when we will compute minus 2 mod 26, this will be equal to 24. In this case, quotient will be equal to minus 1. We can write minus 2 is equal to minus 1 into 26 plus into 24. So minus 2 mod 26 will be equal to 24. Just you have to add minus 2 plus 26. This will give you 24. For example, minus 1 mod 26 will be equal to 25. Then I will use this congruent relation modulo n. So two integers a and b are said to be congruent related if basically we will represent by this notation a congruent to b mod n if n divides the number b minus a. This n divides b minus a can be written as there exists an integer such that b can be written as equal to a plus k. If n divides b minus k, then definitely there exists a number k such that we can write b is equal to a plus kn. For example, a 1 and 27 are congruent relation modulo 26, because when we will subtract 27 by 1, that number will be divisible by 26. Then I will use set of integers modulo n, basically Zn. So basically Zn contains numbers from 0 to n minus 1. So this set is called integer modulo n. For example, Z26 is equal to 0, 1, 2 up to 25. And this set Z2 containing only two numbers 0 and 1, and our all computer systems work on this set 0 and 1 binary system. So in our construction, I will use this type of set, and these are the very basic mathematics. Almost all of you know about this. And with the help of these mathematics, I will construct some cryptographic algorithm that I will discuss later on. Now I will discuss about crypto system. What is crypto system in cryptography subject? So basically, a crypto system is a tuple that contains plain text space, ciphertext space, key space, and the set of all encryption algorithm and decryption algorithm. So basically, I will discuss about encryption and decryption algorithm after some time. So basically, this set P is containing all the possible plain text value. This set C is containing all the ciphertext value. Key is the key space. So basically, this has this property that If we will encrypt a message P with the help of encryption algorithm key, when we will apply the decryption algorithm, we will get the original message P. So in fact, encryption and decryption function are inverse to each other. So this is the property of encryption and decryption algorithm. Now I will give you a very basic example of a crypto system that was used during World War. So first of all, I will take a set Z26 that will contain the integers from 0 to 25. So here the plain text space, ciphertext space, and the state of key space will be Z26. And for a key K, we will design the encryption like this. So basically, this function or this algorithm will give you x plus k mod 27, mod 26. And how we will decrypt the message? So basically, decryption function or decryption algorithm will take a message y and give you the value y minus k mod 26. So basically, this is known as shift cipher, and where we will take the particular value of k, for example, k is equal to 3, that cipher is known as Caesar cipher. And this cipher was used by Julius Caesar during World War, or many years ago. Now I will discuss how to use this shift cipher to convert a English alphabet into another text. For example, suppose I want to encrypt a message Amity. So how we can encrypt Amity with the help of shift cipher? So first of all, I will find a correspondence between English alphabet and integer. For example, A will be denoted by 0, B will be denoted by 1, and Z will be denoted by 25. Now suppose I want to encrypt the message Amity with the help of shift cipher. Then plain text is AMITY. The corresponding set of integer is equal to 0, 12, I is equal to 8, T is equal to 19, Y is 24. Then I will apply this operation x plus 3, just addition. X plus 3 will give you this sequence of integers. And then we will apply modulus 26. So when we will apply mod 26, there will be no effect on integer 3 because 3 is smaller than 26. But this 27 is greater than 26. When we will apply 27 mod 26, we will get equal to 1. And this sequence of integers corresponds to this message, DPLWI. And now I will share this message over an insecure channel. And by showing this encrypted message, no one can guess that original message was Amity. Now, what will be the decryption? So, we will use this function y minus 3 mod 26 to decrypt the message. How receiver will decrypt the message? So, he will take key is equal to 3. That key is available with receiver and sender also. So, the corresponding set of integers will be this y. Then we will apply y minus 3, and then we will apply the mod function on this surface of integer. So 0 mod 26 will be 0, 12 mod 26 will be 12 because 12 is smaller than 26, but minus 2 mod 26 will be equal to 24. Here I am using the property of mod function. And when I will check this table, so basically 0 is corresponding to A, 12 is corresponding to M, 8 is corresponding to I. So in this way, we or receiver can receive the original message Amity. But there is a problem. This scheme is not secure. This scheme was used during World War, but in nowadays we can't use this encryption technique. This was just dummy example to explain encryption and decryption. Why this scheme is not secure? As already I have explained that the key space is equal to Z26, and Z26 is containing only 26 numbers. It means only 26 key is possible. So an attacker can apply the all 26 key to recover the message. For example, attacker will try with the key k is equal to 0. Then he will get this decrypted message, and that message is not meaningful. Then he will take key is equal to 1 and receive another decrypted message. That message is also not meaningful. When attacker will take k is equal to 3, he will receive a meaningful message, MET. It means attacker can guess the value of key. So it means shift cipher is not secure. So this is known as brute force attack. In brute force attack, attacker try or use all possible keys. So in this cipher, the all possible keys are only 26, very small key space. So now I will discuss about another crypto system that is called substitution cipher. This is also an encryption technique that will use a bisective function. I know all of you know about bisective function. Bisective function means one function, one and all two function. So suppose I am taking a bisective function from set of alphabets to set of alphabet, then I will explain how this permutation it can be used to design an encryption algorithm and decryption algorithm. So again here we will take the plain text space and ciphertext space as a set of alphabets. Then we will take the set key. Basically, key was the set of all possible keys. So key will be the set of all permutation on 26 alphabet characters. Then for each permutation, how we will design the encryption algorithm? So basically, encryption of X, encryption of an alphabet will be equal to phi of X, where this function is sending X. So this will be the encrypted message. And while decryption, we will use the inverse permutation. And what is the guarantee that this phi inverse will exist? What is the guarantee? Because we have taken phi as a bisective function, and for a bisective function, 100% inverse will exist. So we can use the inverse function here. So for example, suppose I am taking a permutation. Suppose this permutation is sending A to X, B to N, P to Y, and so on. So basically, this is a function from set of alphabets to another set of alphabets. And the phi inverse will be equal to this A will send to B, because you can see here phi was sending B to A. Then inverse will send you A to B. Then inverse will send you B to L, because phi was sending L to B. So in this case, we have taken a bisective function. You can take any bisective function. Particularly, I have taken this bisective function. Now I will explain how this permutation can be used to encrypt a message. Suppose the plain text or original message is Amity University, and suppose I want to encrypt this message with the help of permutation function. Then what will be the ciphertext where we will apply permutation function on A? We will get it equal to X, because phi is sending A to X. Then M will go to T, because phi is sending M to T. So in this way, we can encrypt a message with the help of this permutation function. Now tell me, what are the number of possible keys here? What are the possible number of keys here? Here, key space is the set of all permutation on a set containing 26 elements. So here, key space is large number. So basically, here key space is factorial 26, and factorial 26 is a very big number. Factorial 26 is almost equal to 2 power 88. It means 2 power 88 possible keys are there. So here brute force attack is not possible. By applying brute force attack, we can't receive we can't decrypt the message, because key size is very large. But another type of attack is possible on this encryption scheme, that is called frequency analysis, that I will skip at the time. You can explore about frequency analysis. This scheme is not secure against frequency analysis. Now, in the beginning, I discussed that there is a limitation in symmetric key encryption. What was the limitation? Sharing the key. How to share a key between two people? Suppose one people is in Ranchi and another is in Delhi. Then how to share a common key? So again, mathematics will give you a method to share a key between two people. Very basic mathematics we will use, that is group theory. So in this Diffie-Hellman key exchange problem, the problem was how to share a common key between sender and receiver. So again here basic mathematics is used. So basically we will use a group in this scheme. So I hope all of you know about group. Group is a set which satisfies some certain condition that I have speaking. Then I will use about cyclic group. So cyclic group means a group that is generated by a single element. So basically a group G is called a cyclic group if this G is generated by a single element. So basically generation of G will be equal to G power n. So this type of group is known as cyclic group. For example, Z10. Z10 is a cyclic group. So now we will use or we will define a problem that is called as discrete log problem. And this problem is very important till nowadays. And the problem is by knowing G power x, basically G is the generator of a group. If you know this element G power x, then it is not possible to recover the value x. Till now, there is no polynomial time algorithm that can solve discrete log problem. But after development of quantum computer, we can solve discrete log problem. But till now, there is no polynomial time algorithm that can find the value of x after knowing the value of G power x. So this will be used by construction of Diffie-Hellman key exchange problem. Another problem is known as computational Diffie-Hellman problem. So by knowing three elements G power A and G power B, it is impossible to compute G power A into B. If you know a group element G power A and G power B, then by knowing these three elements, you can't compute G power AB, and this is known as computational Diffie-Hellman problem. Still, there is no algorithm to solve this problem. Now, how the key will be exchanged? So in setup phase, basically sender and receiver agree on a common set. Suppose on a set G, so basically G is a cyclic group. Then Alice and choose two secret value A and B. A is secret of A and B is secret of B. So here Alice is choosing the secret A and Bob is choosing the secret B. Now what Alice will do? Alice will compute G power A and send this G power A over an insecure channel. Anyone can receive or get the value of G power A, but by knowing the value of G power A, no one can guess about A. After that, Bob will compute G power A power B. He will apply the power on this element, G power B. Then the Bob key will be G power AB. And Bob will compute another value, G power B. Basically, B is the secret of Bob. He will send this value G power B to Alice, and Alice has the value A. He will compute G power AB. So in this way, Alice and Bob both had a same element, G power AB. Alice has also G power AB, and Bob has also G power AB. And this will serve as a common key between Alice and Bob. So basically, the shared secret key will be equal to G power AB. But this scheme is not secure. I am explaining why this scheme is not secure. So basically, this is not secure in man-in-middle attack. So suppose an attacker intercepts the message and establish two keys. How they will establish two keys? Suppose Alice was sending this message G power 8 and attacker intercepts this message G power 8. Then what he will do, in place of sending G power A, he will send G power M to the Bob. So basically, Bob will think that Alice gives the value G power A, but basically Bob has G power M. Similarly, when Bob will share G power B to Alice, again attacker will intercept this message and send another value G power M to Alice. So basically here Alice has G power M and Bob has G power M. So in this case, the key shared between Alice and Bob will be, this will be, the key of Alice will be G power M A. You can see this is the key of Alice, G power A. And the key of Bob is equal to G power B. And both are different. but both Alice and Bob will think that they have the same key. Now, if Alice will send any message, then attacker can easily decrypt that message because attacker knows the value of the power AF. Already he has intercepted the value of CA, he has the value of F. So any message from Alice or Bob can be encrypted and decrypted by this attacker. So this scheme is not secure against this type of attack, but there are some techniques, for example, signature scheme or authentication scheme by which we can make this scheme as a secure. And later I will discuss, if I will get time, then I will discuss about signature scheme. So this is the prevention of attack on Diffie-Hellman key exchange, digital signature, public certificate, authenticated Diffie-Hellman. Now I will discuss about RSA encryption algorithm. Basically, this is very important crypto system. Still, many websites are using. You can check any website where you can get information that this website is using RSA encryption algorithm. So basically, the RSA was invented by these scientists. These are the three cryptographers, Lewis, Samir, and Edmund. And this scheme was invented in 1977. Still, people are using this scheme. And for this invention, these three people got Turing Award in 2002. And this award is almost equal to Nobel Prize in Computer Science. So again, they used very basic mathematics to design RSA encryption algorithm. Very basic mathematics. So now I will explain how RSA encryption was developed. So basically, RSA encryption is based on prime factorization problem. So what is prime factorization problem? Given a large number, you cannot find the prime factorization of that number. Till now, there is no polynomial time algorithm that can factorize a positive integer, big positive integer. So that is known as prime factorization algorithm. But people are working on quantum computer. After development of quantum computer, definitely you can find the prime factorization and RSA we can break with the help of quantum computer. But till now there is no efficient quantum computer algorithm. I mean quantum computers. So this is prime factorization problem, and there is no polynomial time solution for this problem. Now, during construction of RSA, basically these cryptographers use a mathematics function that is called as Euler phi function, phi n. So basically, what this function will give you? So basically, phi n will give you the number which is co-prime to number n. For example, GCD of k comma n will be equal. So how many numbers which are less than n and co-prime to n? This will give you phi n. For example, phi of 6 is equal to 2. When you will take n is equal to 6, only two numbers are co-prime to 6, 1 and 5. So basically, phi of 6 will be equal to 2. When you will take a prime number p, then phi of p will be equal to p minus 1. For example, suppose you are taking a prime number 5. Then 4 number will be co-prime to n, 1, 2, 3, and 4. So phi of p will be equal to p minus 1. And if you will take n equal to p into q, then phi of n will be equal to p minus 1 into q minus 1. You can see this is very basic mathematics that can be used while construction of RSA encryption. Another theorem is Euler's theorem, and according to this theorem, power of any integer a of phi n will be equal to congruent of 1 modulo n. Already I have explained about this solution. So a power phi n is equal to 1 modulus n. Now, what will be the key generation in RSA algorithm? So first of all, a party will generate key generation by choosing two prime numbers p and q. Then he will compute the value of n that will be equal to pq, and then he will compute phi n that will be equal to p minus 1 into p minus 1, q minus 1. After that, he will choose a key with some condition. The condition is the value of e must be between 1 and phi n, such that GCD of E comma phi n is equal to 1. This condition is compulsory and this E will work as an encryption key. Then we will compute D and that will be equal to E inverse modulo phi n. But you may think that what is the guarantee that E inverse will exist? So E inverse will exist because GCD of E comma phi n is equal to 1. So both are co-prime, that's why it is 100% sure that this inverse will exist. Now, in this case, public key will be equal to E comma n and private key will be equal to D. Now, what will be the encryption function? So basically, encryption function will take text P and this function will give you just P power E modulo n. That's a simple function, P power E mod n. This is the encryption in RSA technique. Just basic mathematics. Then decryption is equal to D power D modulo n. When you will put the value of D here, you will get this is equal to P. So basically, this is a diagram of RSA. Suppose Alice wants to send a message to Bob. So Bob first of all generate the public key and secret key. So basically, E and D will be equal to public key and D will be the secret key and E comma n will be public key. So, for example, suppose Alice wants to send a plain text equal to 4. Suppose the message is 4 and he wants to send this message to Bob. Then Alice will compute P power E mod n and the value of E is publicly available, the value of n is publicly available. So easily he can compute this value C and basically this value will be equal to 53. Now Alice will send this 53 over an insecure channel. By knowing this 53, no one can recover the message code. When this 53 will be received by Bob or receiver, he can use the private key D to recover the message. So basically, when we will raise 53 power 47 modulo and we will get the message code. So this is the overall idea of RSA encryption technique. This is very simple encryption technique and still this is used in current situation. This is the correctness part that I am giving. Okay. Now I will discuss about another encryption technique that is known as homomorphic encryption. So now I will discuss about homomorphic encryption. Nowadays, I mean this is the current research area, homomorphic encryption. What is I will first of all explain what this tool. I mean what is we are trying to do here. Suppose Alice wants to compute this function F on some secret method M1, M2, MT. Suppose Alice wants to compute this function on this secret value M, but he has no capability to compute this function. He has no computational power to compute this function. Now he will take the help of a server that has more computational power, but at the same time, he do not want to share his secret input. He don't want to share this M1, M2, MT. Then what he will do? So with the help of homomorphic encryption, this is possible. First of all, he will encrypt this M1, M2, MT and compute the ciphertext and share this encrypted message to cloud server. Then cloud server will use another algorithm that is called evaluation algorithm. It will use a public key, this function and the encrypted message to compute this message. Basically, he will return this encryption of this message, F of M1, M2, MT, and by the secret key, this Alice can receive the function F of M1, M2, and MT. So basically in homomorphic encryption, there are three algorithms. First one is key generation algorithm. Then encryption, basically with the help of encryption, Alice will encrypt the message M1, M2, and MT. Then encryption algorithm and evaluation algorithm. And Basically, evaluation algorithm will give you the encryption of this message. So, for example, I am explaining a very simple, this technique with the help of very simple function. Suppose I am taking the function f that is equal to m1 and m2. M1 is m2. Then we can use the RSA encryption technique to compute this C1 and C2. This is just RSA encryption. C1 and C2 are the ciphertext generated by RSA algorithm. And we will share this C1 and C2 to the cloud server, and cloud server will compute C1 into C2 modulus n. And this will be equal to 69. When we will set 69 to release, we can receive the original message. He can receive the original message 20. Because you can see here, M1 was 4, M2 was 5. So their product is equal to 20. So finally, Alice can get the value 20. So this is all about homomorphic encryption. Then next, I will explain about signature scheme, multi-signature scheme basically. Just I will give the idea of multi-signature. So this is the multi-signature, and people are working on this area, and this is, very hot area because this is used in blockchain and Bitcoin network. So basically, signature is used for authentication. So what was the drawback in signature? Suppose there are 3 people that want to sign a document. So in traditional signature scheme, they will generate 3 signatures. Alice will generate 1 signature, Bob will generate another signature, Carol will generate another signature, and verification algorithm also take 3 computation time. So this is a problem in traditional signature scheme. To remove that problem, multi-signature scheme was proposed. And in multi-signature, all these 3 jointly give you a signature, just like joint account. Suppose someone has opened a joint account in an account, then we can use this multi-signature scheme. So this is used in blockchain Bitcoin network. So basically, you will explore about this Bitcoin network. So there is a multi-signature wallet. Multi-signature wallet means just a joint account. Suppose there are 3 people who are associated with this multi-point or multi-signature wallet. So here we can use the multi-signature scheme to find the aggregated signature, and this will reduce the size of blockchain. Actually, the blockchain is publicly available, and we will always try to reduce the size of blockchain. So with the help of multi-signature scheme, we can reduce the size of blockchain. So that's all. And if you want to explore this multi-signature scheme, you can follow my paper that is published by the Oxford University Space Computer Journal. So you can explore this journal, this paper. So thank you. If you have any other questions.
Anybody have any question one by one? Anyone? Question है किसी का? No. Thank you. Thank you.
Thank you, sir.
ठीक है.
Hi, sir. As a first year student in CSE who wants to move towards theoretical CS or cryptography, what mathematics maturity should be built first? And in modern cryptography research, how important is deep number theory compared to applied algorithms?
So see, to explore this cybersecurity or cryptographic algorithm, first you have to study basic number theory, group theory, that's all. And current research area in cryptography is basically post-quantum cryptography, that we use the lattice-based crypto encryption, LWE, ring SIS problems, that are the algorithm that quantum computer cannot solve. So that
just like the one which you discussed.
Yes. There are some algorithm that algorithm even cannot be solved by quantum computers. So people are working on post-quantum cryptography. So you can explore that area. It's good for.
Thank you, sir.
Thank you, sir, for that highly insightful and enriching session on behalf of the organizing team. We would like to felicitate you as a token of our sincere gratitude. May I request Dr. Ashish sir kindly present the momentum. Let us give a big round of applause. Thank you, sir.
A very good afternoon to all esteemed dignitaries, guests, colleagues, and participants. I, Chanda Mehto, a second-year BTech student from the Department of Computer Science and Engineering, feel extremely honored and privileged to host today's session. I now humbly invite our distinguished speaker, Dr. Kishore Babu Nample, sir, Assistant Professor of Department of Computer Science and Engineering, IIT Ranchi, Jharkhand. Dr. Kishore Babu Nample has been working as Assistant Professor in the Department of Science Mathematics, IIT Ranchi, Jharkhand, India, from March 2025. He completed his PhD in Computer Science and Engineering from Indian Institute of Technology, Roorkee, India, and Master of Technology (MTech) Computer Science and Engineering from Indian Institute of Technology, Roorkee. His research interest is medical imaging, image processing, machine learning, artificial intelligence, security. He has published more than 10 papers in reputed international journals. He has qualified GATE, received Microsoft Research Funds to attend IEEE International Conference, etc. He delivered lectures as invited speaker, keynote speaker, and resource person in various conferences, workshops, FTP, STTP, STC, refresher courses, etc. He was working as assistant professor in Department of Computer Science and Engineering in Vignan's Foundation for Science, Technology and Research, deemed to be university, from June 2017 to December 2018. He is going to deliver on mathematical foundation of multimodal research in computer science. Now, I'd like to invite Sir to stage to share his valuable words and guidance with us.
Thank you for the introduction of myself. Thank you, dear professors, for the invitation And the event is going on very proper way, and the students are very interesting. This is the last part, I feel. So same thing I can put into my part. You can continue with same. Okay. So I'm here to discuss the role of mathematics in computer science. So I came to know that you are all from computer science. So you want to learn mathematics. So how to use the mathematics in computer science? Okay. So I'll take a case study or application. So I want to involve both. I want to include both computer science and mathematics in interesting domain, that is AI and ML part. Okay. So the title is how missions learn and see. Missions learn. Mission learn means it is about mission learning. Mission see means vision. It is about computer vision. So here two domains I am including. Okay. So I'll start with the basics, and I end with the basics only. Okay, because I'm not going very deep in the sense. So I have to derive mathematical equations, derivations. Okay, and some advanced concepts. Only to be covered, but few important things we'll discuss, and we'll see some coding part and implementation part also involved. So AI, you know what is AI? You heard what is AI? AI means artificial intelligence. So AI became more famous than artificial intelligence. So everyone, almost people, they know AI. So artificial intelligence means what? It's not like a sentence with two words. Artificial intelligence means it is a domain, very big domain. Inside that, many other things are there. What? Suppose AI application is there. You are using AI application for any purpose. Just simply you will download and then you will complete the task and then you will go home. Here, our thinking is about the completion of task in a busy schedule. As a student, many subjects, many assignments, right? Family tasks, many other things. We are very busy. So this is the task. Within the time we have to finish, and then we have to go. For that, this process quickly we will download and we will do the process. You will finish the task and then we'll go ahead. But what is the background of AI? What is there inside the AI? Suppose you are using app. So what is the backend? What is there inside the app? How we have to design the app? Means we have to know the basics of artificial intelligence. So artificial intelligence is a big domain. Inside that, machine learning is there. Inside that, deep learning is there. Inside that, many other things are there. Okay. So far, these are the things we'll try to understand. AI, ML, and DL. So AI is a domain, and machine learning is a subset of AI. You know that? And deep learning is subset of ML. Right? So what is the difference? Okay, it is a subset of each other, but what is the difference between AI and ML and DL? Many slides are there, content is there, but I don't want to discuss much. I want to put the content in your brain. I try to cover. So, in case of AI, what is the difference between AI and ML and DL, deep learning? AI means artificial intelligence, ML means machine learning, DL means deep learning. So AI, application oriented. Okay, so what is the difference between AI and ML and DL? AL, it will mimic the human behavior. It is like a high level application. ML, mission learning. It is about the learning of the mission, learning of the computer, learning of the device, learning of the mobile, any device, computing device, learning. How device can learn based on the past data. Suppose if you consider human brain, humans. Okay, so problem is there, equation is there. Okay, so we by heart or we'll understand the equation and solve the problem. Then we will try to solve the new problem based on the same equation. Same thing, right? So past the content what we have done, that is learning. and applying to get the solution for new problems. So the same thing, this is the same idea. It is there in machine learning also, it is there in deep learning also. Sir, but what's the difference between machine learning and deep learning? Machine learning is a learning about the machine, learning of human being, learning of the brain. Okay, so coming to deep learning, it is also learning. But what is the difference? Deep word. You might have heard model, machine learning model, deep learning model. I have to design the model. What is the meaning of model? Model is a one box, black box. We don't know what is there inside. Anybody knows? What is there in the box? Nobody knows. Practically, logically, conceptually, we can say deep learning or machine learning is the box. Inside, few things are there. That is the layers. Okay, so deep learning we can say different types of models. Deep learning model we can say. There are many models already defined. There are many models people are designing, the researchers. Maybe you are also doing the same. Few I can guess. So there are few layers. The purpose of each layer from starting to ending. Model will take the input, it will give the output. So how the model will process the input? How the model will give the output? Will process inside. So what will happen inside the model? How actually input will be processed? What is the role of first layer? What is the role of second layer? What is the role of third layer? What is the role of starting layer? What is the role of last layer? How image, input may be image, input may be text, input may be video, input may be emotions. I'm telling maybe means these are all research domains. If you give the image processing. If you give the video is nothing but collection of images. Video processing. If you give the face detection, face recognition. Application is security part, biometrics. Okay, so each point is one domain. So each domain you can use these machine learning applications and deep learning applications. So where you can use machine learning? Machine learning is like a traditional techniques. It is not having multiple layers. Deep learning means it is a model. It is having more number of layers. Input layer, output layer, in between many layers, hidden layers. The more number of layers, the network is more deep. If it is more deep, it can process the large amount of data. So deep learning model requires large amount of data. If you apply small size data, what will happen? You may not get the proper results. Size of the data set is small, then you can go for machine learning. One student asked the question, what is the difference between ML and DL? Okay, so for small size data, you can go for machine learning, that's fine. You can get the better results. For small size data, if you go for deep learning model, you may not get the proper results. If the data is complex, data size is large, okay, then you go for deep learning model. Okay, so data may be text or image or video or activities, anything. Okay, so slowly we'll discuss some basics. So coming to the data. So you got the idea what is the model. Machine learning model, deep learning model and all. Coming to the data. So based on data, you have to design the model. There is no standard model which is useful for all type of data. The same way, there is no standard data which is suitable for all types of models. That is why still research is going on. For many years, things are going on. Because there is no perfect data set. There is no perfect model. There is no perfect data set which is supporting, which is suitable for all the models. The same way, there is no standard model which is suitable for all the data sets. So new data set is coming. Old models are not suitable for the data. So that's why we are designing the new model. Objective is, goal is, we have to get the results. Whatever the performance metrics we will consider, those metrics, okay. So it will represent the results. The results should maybe accuracy should be more, the loss should be minimum, optimization, cost should be less, accuracy should be more, right? So these are optimization. Optimization means what should be maximized, what should be minimized. You have to focus. Based on that, you have to write the code. Coming to this, machine learning, deep learning, AI, which programming language is important? Mostly Python. You can implement using C also. You can implement using C++ also. But what's the difficulty? The libraries, what you have to import, the models, what you can use, those are available for machine learning deep learning from the Python. So mostly people are using Python. And tools also there. Right. So in case of tool, what is the disadvantage? Few things are installed. You have to use that only. Otherwise, you have to install tool. So instead of using tool, better to write the code. As a computer science students, you know, programming is important, right? So after placement, maybe you go for C++ programming for course or projects, and then after that you may go for machine learning or deep learning. Definitely will go. Maybe you don't know now, but definitely will go for that, right? So then you have to use Python. So now I'm discussing about the data. Data, based on data, you have to design the model. So we have to understand what is data. Data are two types. Data, labeled data, unlabeled data. Labeled data, data can have labels. So like this, the cat is having a label, dog is having a label. So that is labeled data. Other side, unlabeled data, image is there, but label is not there. You know what is that, cat or dog, but mission doesn't know. So then how she will come to know, or how the mission will come to know? It should extract the features from the image. Those features should be processed. The processing of features should be done in a proper way. For that, you have to design the model, or you have to use a pre-processing model, or you have to use a post-processing model. And you have to get the results. Your result should be better than previous models. Then only you can say your work is done in a proper way. Just I'm talking your course level project. So data is about labeled data, unlabeled data. Right. So in case of labeled data, what type of model you have to use? In case of unlabeled data, what type of model you have to use? You might have heard labeled data, they are learning. Coming to the visual learning. So about the data, labeled data, unlabeled data. Right. We go for other type of data, continuous data, discrete data. You know what is the meaning of labeled and unlabeled? Now we go for the model. What type of model can be used for labeled data? What type of model can be used for unlabeled data? In case of labeled data, you can go for supervised learning. If we talk about the learning, machine learning, there are types of learning techniques. Supervised learning, unsupervised learning, reinforcement learning. I can say one more, semi-supervised learning. So based on data type, I'm dividing the models, learning models. Supervised means you can use labeled data. The content is mentioned here, right? Labeled data can go for supervised learning. Unlabeled data can go for unsupervised learning. Sir, how it will process? What about the semi-supervised learning? Suppose labeled data is something labeled. Out of 100% of data, 20% is labeled data. 80% is unlabeled data. Then we'll go for semi-supervised. Semi-supervised means supervised will go for labeled data, and then you will train the model. So that model you can use for unlabeled data for the testing. The data we have to divide into train data, test data, validation data. We will train the model using train data. And then once model is trained, once model is done with the learning, then we have to go for the testing. So then we have to use test data. Right. So this is just a basic idea about the project work. So yes, I will give mathematical example. So coming to one more type of data, data is two types. One we discussed is labeled data, unlabeled data. One more thing is continuous data, discrete data. Continuous data, for that, few techniques we have to use. Few techniques we should not use. What are those? In case of discrete data, what are the techniques we can use? This is the example for labeled data. Label data means the label what you are seeing, the last column, this is the label, right? If you see, the label data can be represented in the form of two values, X and Y. Y is label, X is input features. Here in case of unlabeled data, only X is there. There is no label. There is no label. So that is, this can be used by unsupervised learning. And labeled data can be used by supervised learning. Example for supervised learning is regression and classification. Example for unsupervised learning, clustering. You remember these words? We'll discuss few things about this with the help of coding part. So numerically, if you see, same thing will implement using code, the same thing I'm showing using mathematical calculations. In case of machine learning code is a one-line code, but in backend what is going on? So these are the mathematical calculations are going on. So this is the data. Label is Y. These are remaining values of X. Okay, so label is there. So that's why this is label data. So model is supervised learning model. So this is unlabeled data. There is no label. Only X value is there. There is no Y value. Semi-supervised, just partially some amount of data may be labeled, some amount of data is not labeled, unlabeled. So then you will go for semi-supervised. The model, coming to the models, data analysis models, the models what we can use for the data sets. Maybe continuous data, discrete data, or labeled data, unlabeled data. So models are, these are the models. That's what we already discussed in the table. Going for the first model, regression. Regression is example for supervised learning. It will use what type of data? Continuous data. Okay. We'll see the example for this. Coming to the regression. So this is a regression model. This is the general equation, mathematical equation. The inputs are x1, x2, x up to xn. Y is a label. Might have seen the table. The last column is label. The remaining columns are features like x values. So here x1, x2, x3 you have to represent in the form of this equation. This is general equation. Okay. So we go for different types of models. These are the different types of models of regression. One is simple linear regression, and then multiple linear regression, and so on. This is general equation for regression model. We'll go for simple regression. I'll try to explain with the clarity. Try to understand with this. It is one independent variable and one dependent variable. So x value is one column, label is one column. So then it is simple linear regression. So this is dependent variable y value and independent variable x. So this is a line equation. Y equal to mx plus c. The importance of mass I'm discussing. In case of computer science or programming part. Okay, so this is the line equation. Y equal to mx plus c. Very basic equation for line. So here input is x, label is y, parameter is theta 0, theta 1. These are the parameters. We can say this is the model. X is input, y is output. But y is expected output. X is input. Then mission will be trying, will get the output. That is actual output. Expected output is there. That is y. Actual output we are getting. Right. So expected output minus actual output. That is the error. If model is good, the design model is performing good. Our work is good means accuracy should be more. The difference between expected output and the actual output should be, there is error. Minus, we subtract. Expected output minus actual output. Difference is error. You have to minimize the error. You have to optimize the model, nothing but you have to minimize the error. You have to maximize the accuracy. So that is what this line. Okay, so now we solve one problem with this. Try to understand. So this is a data set. X one column, Y one column, nothing but simple linear regression. If there are more X values, more columns, that is multiple linear regression. Okay, so one X, one Y. So Y equal to Mx plus C. We have to find out theta 0, theta 1 to optimize the model. Okay, so X is given, Y is expected. So we have to find out the mean, and then we have to find out theta 1. Theta 1, nothing but beta 1. Are you getting my point? So here, theta 0, theta 1 are the parameters. X is input, Y is expected output. We will run the model, we will get the output. Expected output is there, actual output is there. Difference is error. So error is less, performance is good. The same way, just the process is this. You have to find out theta 0, theta 1. Nothing but here, beta 0, beta 1. Beta 1 you have to calculate using formula. And then beta 0 you have to calculate using the formula. That is a mathematical calculations part. Right? Solving equations, mathematical equations. X1 equal to x2 equal to 10, y1 equal to y2 equal to something. Then you have to find out the x1 value, y1 value. So the basic mathematical finding the solution for the equations. So you will find out the x y equal to 42.5 plus 7x. We have calculated the parameter values, theta 0, theta 1. Means model is trained, parameters are calculated. Model is trained, parameters are calculated. Now we have to go for testing. Previously, what are the value? X value is trained data. Now we are giving model is trained. Now we have to go for the testing. If we give one more value x, you have to find out the y value. So if we give one more value x, this is 5, then you will find the y value is 77.5 something. Okay, so first model is equation, and then input is x, expected output is y. The theta 0, theta 1 is the parameters what we have to calculate after training the model. Machine learning model, I am representing the form of simple equation. If you understand this, you can understand the basic idea, so that you can go for machine learning or deep learning. Model is equation. X you are giving, y you are getting, y equal to f of x. F of x is a function. F of x is nothing but model. This is machine learning model. This is deep learning model. F of x is nothing but a model. So that is how you will get the values. One more example for this. The same calculations you can see. This I am trying to run. This link is not working. The Python example program is there, but unfortunately link is not working. Then my lab is working. Can someone empty PDF file? PDF हो जाएगा? I'll show you one or two examples. I don't want to take much time. So, just I want to show you the ID where you can run the program. Maybe you are working in Polar, Google Colab. The same way, here you can use GPU, right? So, for deep learning models, to use large size data set, you need GPU. Okay, so Colab is providing GPU. And one more website is Kaggle. Kaggle is also providing GPU. That is also very good website. Data sets you can download, you can write your own code. Okay, so I think, yeah, I can see your faces so that yes, answer. So simple for this concept is I'm running the code. So what button we have to press to run the code? Google Colab. Key, shortcut keys. Simply enter. Here it is not signed in. Okay, I'm skipping this implementation part. Okay, so simple line code. Okay, so just we will import the libraries. Anyway, your experience with the Google Colab tag. Okay, simply import the model and use the model to train to test. That's it. Okay, but you got the clarity with the mathematical calculations and importing and running using Python is not difficult task for CSC students. The same way, multiple linear regression. We go for it. So x values are more than 1. So here two values are there, x1 and x2. So this is y is expected output. Okay, it is a labeled data, right? So this is, can you answer what which type of data it is? Continuous data, discrete data. So whatever the numerical data, mostly it is continuous data. Continuous data means we have to predict the next value. So here we will train the model, we will give the input, next value we predict. Discrete data means categorical data. That data will be used for classification, not for regression. So regression is different, classification is different. Regression we use continuous data. Classification we use discrete data, categorical data. Categorical data means classical. It is used for classification. We go for classification. So this is multiple x values are there and y value is labeled. So this is known as multiple linear regression. In case of single linear regression, what we have done? The equation is there. There is a model, right? So here input is x1, x2, expected output is y. So you have to write this one in the form of equation. Equation is nothing but model. You are writing the code to design the model. Mathematically, this is the equation to design the model. Okay, then we have to train. Train means here I am writing this. This data can be represented in the form of equation. X1, x2 are input features. Y is output label. Right. So here beta naught, beta 1, beta 2. The parameters, the value of parameters we have to find. Nothing but we have to train the model. After training the model, you can calculate the values of parameters. Right? So after that, you can find the line equation. So this is the simple rotation. It is a very big mathematical derivation. After that, you can get it. It's like a system of linear equations. Mathematical concept. So you have to represent the equations in the form of matrix. Okay. So y values you have to represent in the form of one matrix, one vector, and x values we have to represent in the form of one vector, right? So the same way, the parameters we have to represent in the form of one vector, And then finally you have to find the values of parameters. So this is the system of representation, equation system representation, system may be homogeneous or heterogeneous. So this is the finally the equation to find out the parameters. So this is simple example for this multiple. Suppose data is, in this case data is linear. Suppose data is non-linear, then you will go for other models. Linear, simple linear, multiple linear. If data is non-linear, we will go for polynomial regression. Okay, so based on data, we go for the different model. Clear? So diagrammatically we can represent this is the data, simple linear regression. The data can be separable by single line. So that is linear data. Suppose here this is also linear, but multiple linear regression. Okay, so suppose data representation of data in the form of graph. If data is more like a more non-linear feature, then we'll go for polynomial or we'll go for deep learning network. Right? Okay. So using this, if data is non-linear, then this is how we'll draw the line. It's not a straight line. Simply it's going like curve type. Data is more linear. If you try the model again and again, the line may be like a more curvy. Right? So this is about polynomial regression. So in the same way, few more regression techniques are there. Based on the data type, you go for the model. Right? So this is for continuous data. Now if you go for the data is discrete data. Discrete data means categorical data. The categorical means the classification. We go for classification. Then what are the different types of models? The types are binary classification. Data is having two types. One category and other category. On one category, multiple number of images, any number of images. Data set is small. You go for traditional machine learning models. Data set size is large. You go for pre-trained models. Have you heard the name pre-trained models? The model we have to design. Usually what we do, we train the model. We will give the input, we train the model. We get the output. That is what we will do. Suppose my question is, data set size is small, but I want to use a deep learning model. Deep learning model can run with large data set size. But the data set size is small. I want to use deep learning. How? You can go for pre-trained models. Pre-trained means the models are already trained, the parameter values are already calculated. Those are there. Just take the weights, take the parameters, just use with your model. Simply go for the test data, you can test. Clear? So different types of classification. Binary classification, two types data, multi-class, more than two, multi-label classification, slightly advanced concept case of classification. So regression and classification, what is the difference between regression and classification? Regression is for continuous data, classification for categorical data, discrete data. So here, what type of loss function? You know one thing, you cannot use one loss function for all the models. You have to use particular loss function for particular model. Knowingly, unknowingly, if you use any random loss function with one model, will not get proper results. That's what the mean. So these are the process of force project. First, what we will do? The problem we will decide, and then we will go for the data collection. Right? So in case of data collection, we collect the data, whatever the data you want, and whatever the work you want to work on the total data. We will have the labels. The classification is what type of learning? Supervisor learning. Supervisor learning means label data. It is using what? Labels. X and Y both. Next, after collecting the data, you have to process the data. So there are multiple pre-processing techniques so that you can train the model properly and you can get the results properly. And then feature selection. While processing, the difference between ML and DL. I'm again answering the question. What is the difference between ML and DL in case of many perspectives? One is in case of feature extraction, what is the difference between ML and DL? DL, deep learning network, is a collection of model layers. Okay, if you consider CNN, have you heard the name CNN?
Yes, sir.
What is convolutional neural network? The C stands for convolutional. What does mean? Convolution means. Convolution means it will divide the image. Big size image will be divided into small parts. Those are known as features. Features will be processed, right, based on features. Okay, based on processing, we get the results properly. Based on the accuracy value, precision value, recall value, we will get in a proper way. If you are not getting means the process is not done properly. So then you have to apply pre-processing technique, and we will go for post-processing technique also to improve the results. Right. So this is the flow of project. A person how we usually be as a student, how we will do. Decide the problem, collect the data, and then data processing, and then go for feature selection, and then split the data. Data can be divided into test data, trial data, validation data, and then select the model. If data set size is small, go for machine learning model. Just select additionally, and then you run the model, get the results. Suppose data set size is large, in place of this, you can go for any deep learning model, either pre-trained model, or you can design the model, then you can train the model. That is what is important. Then after designing the model, you will train the model, and then you will predict. And then you can evaluate the model based on the performance matrix. The results can be represented in the form of matrix. Those metrics are known as performance metrics. And then finally, you can go for optimization. It's like a part of post-processing technique, hyperparameter tuning, feature engineering, and few more advanced algorithms you can use for it. Coming to the classification, this is general process what we have discussed. There are different types of classification algorithms. These are traditional machine learning algorithms. You might have seen these are all old models, but still people are using this. Those who know actual research, they are not using these models. You have to go for advanced models, advanced content. These are traditional machine learning models. If you use this, you will not get the recognition. Don't use this just for learning purpose. I'm showing. Right. So classify logistic regression. So the purpose when we can use test cases, not use cases. Logistic regression we can use for this classification. In case of binary classification, alias driver, so pattern recognition, small data sets you can use this. Decision trees, random forest, support vector, mission name base. Right. So these are the people. Here I mentioned neural networks. Neural networks. The actual advanced research will start from neural networks. Neuron, it is similar to human brain. How brain will take the input, how it will process, how it will give output. The brain neuron structure, you know. So there are multiple small nodes. Nodes are connected to each other. Okay, thousands of numbers of nodes are there in each neuron. And multiple nodes in a neuron. Multiple neurons will be connected to each other. This is what you cannot assume how many number of neurons are there. That is what the deep means. The deep learning means this is what the word deep means multiple layers, more number of layers. Input layer is there, output layer is there. In between hidden layers are there. How many number of layers? You can include any number of layers. More number of layers, more better results you can get. That is what the meaning of deep. Right. So these are the basic traditional machine learning algorithms. A type of algorithm, type, and then the algorithms. These are basic idea. You know that. And the fact that training speed, prediction speed, the overfitting. What do you mean by overfitting? You divide the data into train, test, validation. The model is there. You train the model using train data. You are getting good results. Accuracy is 95%. Okay. But if you go for test data, you are not getting that much. Maybe 50%. Is a flaw, right? That is known as overfitting. For that, what you have to do? There are a few techniques for that. In the same way, many problems are there. Further, algorithms are also there. So study those algorithms, try to implement, use it, try to implement, improve the model design, get the better results. So these are classifiers, specific class function you have to use. Suppose this function you cannot use with this classifier. You may get the result, but not proper results. Okay, so coding part also easy. So in this laptop is not supporting, it will take time also. So classification, just how we discuss the regression model, just import the model, just find the model, use the data, get the results. The same way, one line code. Okay. Next, clustering. Clustering, the data is two types, labeled and unlabeled. Labeled data we are using for what type of learning? Supervisor learning. Supervisor learning example for regression classification. Now we are going for unlabeled data. Unlabeled data means label is not there. Only X value is there, Y value is not there. Then how model will process? Just will take the content and features from the data, it will recognize the patterns. That's it. For example, there are multiple techniques are there based on clustering technique. Partition based clustering, IRC and so on. The K-means clustering, for example, K-means clustering. Clustering means group. Data set you are giving. For example, data points are there. Okay, so few points are having similar features. Then you have to make those features into one group. There is a cluster. Forming clusters is nothing but clustering. For that, these algorithms are there. Simple. Like classification of regression algorithms, it is also like a just simply download the model or import the model. Simply can run. But traditional machine learning is nothing. Simply just import, give the data, get the output. Right? Because these are few basics. So mathematically, it's like a similar features means it will be calculated based on distance. 2 points are there. 1 point means x and y. 2 points means let us consider x1, y1, x2, y2. Okay, so distance is small. Okay, these two are similar. So those 2 points will be grouped. Like that, similar data points will be grouped or kept at one place. That is one cluster. That means the clustering one. So for this, 2 algorithms. Next, we go for the vision. Whatever the thing we have discussed so far, is that learning. Mission will learn, will give the data, train data. Mission will train, means mission will learn. Then you can test. Therefore, after training, mission is ready. What to do? Then you will get the test data. Then you will get the test output. That's what the learning, mission learning. Next, if you go for computer vision, how the computer will see, means will give the data. Computer will see the data, will take the features from the image, then will process. So mainly focus on taking the data, acquiring the data, processing visual data, extracting meaningful information with features from the input data, and then making decisions, predictions. Predictions means predictions and then decisions. This is the story where the is about evaluation of computer vision started in 1960s, starting with computer vision basics, and then edge detection came into the picture. After that, vision with image segmentation came into the picture. After that, picture extraction techniques, and then 2000s, the machine learning came into the picture. After that, deep learning. Now, real-time CV we are using, real-time computer vision. The real-time means a very advanced, not traditional machine learning models. Advanced means completely starting from neural networks, advanced deep learning networks. So, basic definition is study of algorithm that extract useful information from the images, input data. Data may be anything. You can give the text, it will take as an image as an input, it will collect the features, some meaningful information, and then it will be processed. Okay, so human vision and computer vision. Computer vision, that's what I exist. Human vision means the difference is human vision. Here, in case of human vision, process unit is brain. In case of computer vision, processing unit is computer. In case of sensor, what is the sensor? In case of human vision, the eye is the sensor. In case of computer vision, the camera sensor is a play the role of sensor. The same way, few other things. In case of learning, in case of human vision, the biologically you can learn using the brain, using the common sense. In case of computer vision, the deep learning, machine learning are the main factors. So the same thing here. The important point is humans understand meanings naturally. The computer analyzes the numbers mathematically. The data, suppose if we give the image as an input, how image will be processed? Image will be represented in the form of matrix. Right? Matrix is nothing but a collection of points known as pixels. Each pixel is having value, color value. Right? So suppose 8-bit image combinations are 2 power 8, 256, 0 to 255. 255 colors are possible with the 8-bit image. So like that, if you consider images of different types, black and white image, gray level image, color image. Suppose RGB color image is there. Color image, there are different colors. They are also important. Which color space you have to use? RGB, HUV, LAB. So which color space you have to use for image? After giving the data, while processing, we don't get the proper results. You have to change the color space. What image type is there? JPEG, PNG, BMP. Few types are there. So which is suitable? Because of light, image can be changed. The properties of image can be changed. That you cannot use for the research. You cannot expect the proper results. That's what the importance of this. Few things I skipped. So these are the domains. Different domains. What are the different type of applications? Okay, you can go using computer vision. Just I'll take 5 minutes for this. Deep learning for computer vision. So deep learning, we go for pre-trained models. What are the pre-trained models? So mainly here computer vision will be used for this image classification. Can classify image any data type, and then detection, object detection, and then recognition, and medical image. And many are there. You can use almost all the domains. That is important of deep learning. Neural network. So here also.
सर किसी का बस है तो वो जा सकता है, हाँ बस वाले बच्चे जा सकते हैं, ओनली बस वाले। बस वाले बच्चे ओनली बस वाले जिसका बस है।
So model is a mathematical equation what we discussed already. So this is the model mathematical equation. The inputs are x1 and x2. Y is expected output. Y is bias to improve the results. So different activation functions. So we have to use with the different models and different purposes. For binary classification, we have to use sigmoid function. But in general multi-class classification, we have to go for softmax. And then for other purposes, we have to use particular activation function. So in case of neural networks, these are different types: feed-forward neural network, and convolutional neural network, recurrent neural network. So these are known words. I'll take one example. I'll explain. CNN. So CNN is having different layers. So as we discussed, the deep learning model is nothing but collection of layers. There are different layers starting to ending. So if you see, I'll go for the model. CNN architecture this is. So it is having different layers. You can repeat the layer number of times. It means modify the model. So convolution layer. Convolution means the image will be processed using filter or kernel, the size of the input image will be reduced to next level. Again, if you apply convolution, again, the reduced image again will be reduced further. Means the larger input image will be divided into small parts. These are known as features. Okay, or those features will be arranged in a 1D vector, and further you can divide that into classes. It is binary class. Those features will be divided into two categories. It is multi-class classification. You can divide those features into multiple classes. That's what the meaning is. So these are the different layers. Transfer learning. Suppose data set size is small. Deep learning model, if you want to use, you can go for transfer learning. Transfer learning means already pre-trained models are there. Then you have to use those models for your data. So these are the applications. There are different types of models. This is one model. It is designed in 1998. So it is having only 3 layers. The first successful CNN. Next is AlexNet. Next, VCCNet. So I think many of you are working with this. I know. Okay. But try to move from traditional machine learning, try to move to deep learning. ResNet, because of residual property, is very good results. People are using nowadays this also, but you can think of it. The mobile net. After training, the model will generate the number of parameters. The number of parameters are more. The model is more weight. But it is a lightweight model. It will generate less number of weights. So this is more important among all models. Also, it will give a better performance with any type of data. You can try if you want. So these are the different models based on parameters. We can check the performance analysis. So which one is better in this case? Depth and speed and number of parameters. If parameters are high, weighted model. So low, lightweight model. So lightweight model is preferable for research purpose. And training and optimization further. So this is what basic idea about the deep learning. So further, if you want to improve the model design or if you want to improve the results, then you can go for other training models. Forward propagation, loss calculation, you can use multiple loss calculation, or you can propose your own loss calculation, loss function. You can propose your own loss function. The back propagation, going forward, coming back. It means again you will go forward. These multiple iterations of the problem, so that you can improve the results. So this plays important role in case of deep learning. Without this, it's not a meaningful advanced deep learning networks. Back propagation is important. So recent learning conferences, you know, conference category, A star conference, A conference, B conference, C conference, and journals, Q1 journal, Q2 journal, Q3 journals. You refer A star papers. So these type of problems you can find. So my suggestion is refer quality papers. So that quality content you will learn and quality work you can do. Don't go for low quality papers. Don't refer. Otherwise, you will learn that only. You cannot go ahead properly. So these are different types of optimization algorithms. You can use different types of optimization algorithm for the different purposes. So overfitting. I mentioned one point. Overfitting. So to find the solution for this, different solutions are there. Dropout, data augmentation, right? Regularization, early stopping. These are the deep learning terminologies. So these are the few applications. So I don't know, like more time. These simple applications you can run it. The code is given, but I'm unable to run it here. So what I can share the PPT, you can run the code. Emotion recognition. So just if the data set and the code is there, you can give the data set as an input and then you can go for the output. So with this, I can close my session. Thank you.
Do you have any question? You can ask.
Raise your hand. Mike. Sir,
Good afternoon, sir. So myself Devashish Rana, and I aspire to be a data scientist. So therefore, what are the concepts in mathematics that I should be really working and focusing on? And my second question is, being a data scientist, do I need to be in the domain of deep learning? And if I need to be in deep learning domain, what is the limit I should know? That is, given this domain is very vast, what are the limits of it? I should know about it as well.
So, knowing about the limits is like a question is valid question, but answer is a very big answer, right? But mathematics are important. Without mathematics, deep learning is not there. Okay, based on context, you have to derive the mathematics. You have to go for the mathematics. See, input is x, output is y. The function is f of x. The simple definition is mathematics is there. Without mathematics, then deep learning means nothing. Okay, so based on the algorithms, there are different types of mathematical derivations, stochastic gradient derivation, right? So you want to find out the change, you have to calculate the derivation, right? Without derivation, you cannot change. You cannot find the change. If you don't find the change, you cannot find the edge in the image. One color to other color in the image. Or if you want to observe the change in the color, it means there is a change in the image. There is a line is there, but it's known as edge. To find that change, you have to use the derivations. Some cases, integrations you have to use. So mathematics are compulsory. If you have mathematical knowledge, it is easy for you. And one more suggestion. Repeat the question. What question?
So my
I got it. So what is the limit? Then what is
deep learning.
Deep learning. So limit is like it is unlimited. Okay. AI is a vast. And there machine learning is a limit. Deep learning means how much you can. That's what you can do. The only thing is just motivate yourself. Start working with a recent trend. Sir, how to find the recent trend in the research in particular domain? Check the publications, good journals, good conferences, patents. These are the parameters usually many IITs, NITs, they are considering the recent trend. What is the recent trend means? Recent publications by good scientists, good researchers, good professors.
So any platform to access these quality materials?
Yes, platform is a Google Scholar is a website. If you type the title, you can see the published paper. Okay. I don't know whether I can use this. Let me try. Any platforms are there. Only thing is you should know how to use those resources. So Google Scholar on website is there. That is for research. Also the PhD students they are using Google Scholar, right? So there if you type the title, the paper will come. So there you can check in which conference paper is published, which journal paper is published. The conference rank. How to find out the conference rank? Paper is there, but what type of category, what type of quality we have to understand. For that, you should have some knowledge. Good paper, we have to prefer, right?
So, and for even patents, as I'm also interested in patents and innovation, so any platform specific for that so that I can take it.
Patent, you have to collaborate with the faculty. Professors are there, they are very well experienced, right? So contact, patent, we need experience. For that, guidance is important.
Okay, thank you, sir.
Good questions. Thank you for the question.
Good afternoon, sir. My name is Shreyash. And first of all, thank you for sharing your knowledge with us. So, sir, as you told that models like random forest, ANN, these are traditional models which we use. And generally, we should avoid using them in like deep learning and other. So, sir, can you suggest us some models which are more modern and advanced for deep learning?
Okay, see, important question. See, machine learning models are not good for telling. So we have to go for deep learning models. What type of models we have to go? So where it is available? Okay, new model means if you take already existing model, what is the meaning of research? Right, design the model. Learn how to design. Can you design your own deep learning model? Yes, you can design. What is a deep learning model? Try to learn. Deep learning is just collection of layers. Okay, so how to prepare, how to design our own model? Design your own model, take the data, find the model, get the results. Basic you can do, that is also very easy. Okay, so slowly, just practice like this and go for the advanced. And then if you see research paper, they are providing a code also. Any published paper if you find, okay, good paper, you go for it, and then you see the code also. They provide the code also. How they are using deep learning, how they implemented, everything is there in the paper. You read the paper. Paper is research paper. Research paper you read, so how they took the data set, how they process the data set, right? So how they implemented the coding part, how they produce the results. Analysis of results also important. So how they have done. Everything is there in the paper. Only thing is just to focus on the paper, take the help of professors, definitely can do it.
Thank you, sir.
Yeah.
Sir, would you please brief about generative deep learning?
Generative, the name it is there, generative. Generative AI, the trending one. AI, advanced, many things are there, agents, generative AI, and using these many applications are there. Right, so generative is not about generation. They are also using these type of concepts, AI concepts. If you consider anything, inside something is there. So what is that? That is our basic knowledge with advanced technology. Generative AI is also AI, slightly advanced concept. It will generate the things, maybe image, maybe text, maybe video. ChatGPT, if you type, generate the video, it is generating. Inside it is there something AI. So these are the things it is there. Okay, so you also can do, you also can implement these other things. Generative AI is simply AI. Okay, it can generate few things like text or image or video, few other things. In simple science.
Any other question? Okay.
Thank you, sir, for that highly insightful and enriching session. On behalf of the organizing team, we would like to felicitate you as a token of our sincere gratitude. May I request Dr. Raju Prajapati, sir, to kindly present the moment.
सबसे जी मैं एक मिनट बस तो एक मिनट हाँ एक आपके सजा एक इधर से ले लेना एक So tomorrow you will join online by the Zoom link. Same. Clear? Thank you, Arjun.